All right, well, I would like to welcome everyone to the Core CM Powder River Basin Annual Forum. We're very excited to be here in Billings, and thank you all for your attendance and your interest and participation in this project. I'm Erin Phillips. I am the Program Manager for Critical Minerals at the University of Wyoming School of Energy Resources and the Principal Investigator for the Powder River Basin Core CM project. I'd like to start this morning by just stating our goal for the Core CM project. And that's to establish strategies around critical minerals and carbon ore to build out supply chains in the Powder River Basin and help to build new industries, really with a focus on economic development and workforce development. Our agenda today consists of update talks this morning from our team, our task leads and our co-task leads, and a number of students from the University of Wyoming. Then we'll have lunch. After lunch, we have two keynote presentations by Senator Dwayne Ankney and Mayor John Williams from Colstrip. After the keynotes, we have 3 panel discussion sessions, so really looking forward to those as well. I'd like to note that a strong stakeholder network is essential in building out these supply chains and new industries in the Powder River Basin. So again, your participation here is much appreciated. Core CM project, large team effort. So it's been a real privilege to work with this Core CM team. So thank you all. I'd like to specifically thank Christine Reed for all of her outreach efforts and for her hard work on this forum. Also, thank you to Kyle Summerfield and David Lukey for their help with the forum. Atchison, Cannon Lurkins, Ryan Davison, and Jay Gunderson for their help organizing the forum on the Montana side. And a big thank you to all the speakers today, the panelists and the moderators. Really appreciate your time and effort here. Thank you to our forum sponsors, Waypoints Wyoming and Western Skies Strategies. And I'd also like to recognize representation from Congressman Rosen for the meeting today. We'll first be sharing our progress on the Core CM project and really would like to identify places that we can collaborate with other people in the room, continuing to build this stakeholder network across the Powder River Basin. We're here today to place-based Montana topics and challenges and really continue to build out partnerships across the Wyoming-Montana border and build up partnerships with partners across the Powder River Basin. So again, thank you for being here. With that, I'm going to turn it over to Representative Gary Perry, Montana Representative Gary Perry, for some additional welcoming remarks.
I only represent one district in Montana, not the whole state. I really don't see myself as a great public speaker, but I do see myself as a proud Eastern Montanan. And I want to be sure that each of you, on behalf of myself, the Montana House of Representatives, and all of Eastern Montana, know that you are welcome to our part of this world. As we see the constant assault on the fossil fuels industry and on the coal industry in particular, it's a breath of fresh air to know that there are folks like all of you who recognize that coal is a resource that conceivably holds the key to even more valuable and critical resources to our national defense and security. I've been doing a fair amount of reading and studying and research and attending conferences regarding coal and the possible uses of coal and the byproducts of coal. As probably all of you know, but was a surprise to me, coal across the nation inherently has a significant amount of rare earth minerals incorporated even within the coal naturally before it's burned. With the vast amount of coal in our nation, I see this fact as a very encouraging prospect for all of our future. My excitement here further stems from the possibility that we may have the capability to recover significant critical minerals from the coal and coal ash in an economically viable manner. We'll learn how to recover and process these minerals by the scientists and engineers assembled here who are working on this daily. And that for me is very encouraging. But then my real concern is focused on my understanding that our country doesn't even have the facilities to actually convert the recovered minerals into some usable form for our defense. We need to be working together to develop such a facility in our region. And that's, again, why I'm really excited that we're here today. At this point, we are required to obtain these minerals, as you know, from China. We don't need that. We need to push the work being highlighted here to that point where we are no longer dependent on a hostile government for critical resources and for our defense. As I've scanned the list of topics in the state and the slate of experts who are here to share the work that is being done in a cooperative and concerted manner, I have to admit that I'm excited to listen and learn. For Montana, and especially Eastern Montana, your work represents jobs and possible industrial development that our state will welcome. You have my assurance that I will continue to work for the development and beneficial use of these resources, and I welcome everything that you are working on and everything that it will eventually mean to this state and to our country. Last night when we visited at the reception, I really got a sense of the opportunity that's here for Montana and Wyoming to band together and do some great things. So I'm already planning on heading down to Wyoming and visiting the Energy Department. I'm working on some legislation to try to establish an energy authority in Montana, similar to what Wyoming has started, and it's in its infancy stages, I understand. Of course, infancy has, the top of discussion, but anyway, I'd like to see the policy for the state be established by the state. So anyway, I'm working on that, and I plan on visiting some folks down in Wyoming for furthering that as well. So the other thing I'm working hard on is nuclear projects and trying to see if we can't bring nuclear into Montana. One of the things that is discouraging to me is that there's a long time frame for all of this stuff that we're working on. So my goal is I hope I can get some of this done before I die. So on behalf of Montana, thank you for all you are doing and for sharing it with all of us in attendance here at this forum, and welcome.
Thank you, Representative Perry. Next, we will have some remarks by Scott Quillinan, who's the Senior Director of Research at the University of Wyoming School of Energy Resources.
All right, thank you, Aaron. Welcome, everyone. So this is one of the favorite parts of my job, is getting all of these wonderful people together in the same room, bunch of different disciplines, working all on common issues. And that's exactly what we have here. Aaron said that we have a busy morning, so to keep my remarks short and to give a plug for School of Energy Resources. So here's my shameless plug for School of Energy Resources. Our mission is energy-driven economic development for Wyoming. We were established in 2006 by the Wyoming legislature to work on energy and mineral resources that are going to advantage the state and the region as we move forward. And that's exactly what this program is doing. We're working across state lines, one basin. The Powder River Basin doesn't actually care that there's two states that share it. So really excited to be here today to listen to all the ideas, the issues, the path forward, the opportunities, and really combine and see what we can get some momentum in this space. So continue my shameless plug with School of Energy Resources. Three of our main programs. The first one is our carbon engineering program. It's working, trying to figure out new ways to use coal. How can we take coal and do something else besides burning it? And so this program, if you come and visit us down at the University of Wyoming, we'll take you to a demonstration house that's built out of coal-derived materials. We'll show you how you can make coal or asphalt road paving out of coal. We'll show you what we're doing with soil amendments in place of agricultural products. These are all high volume uses of coal that give us new ways to use it besides depending completely on thermal generation sales for coal. Another program that I'm really proud of that we have at School of Energy Resources is carbon capture and storage. We work a lot on point source carbon capture and storage. We really want to see carbon capture and storage on a coal-fired utility. We want to do it in Wyoming, and we want to do it successfully, economically, and we want to take all of those ideas, all those methods that have been developed, we want to export them around the country wherever Powder River Basin coal is being shipped, to work with those utilities, those operators, to show them what their carbon management opportunities are. So our third carbon products is our rare earth element program. And so I think one more thank you that we need to give is to Dr. Phillips here, who one day came into my office and said, hey, I've got an idea for a program that we can pull together that's going to pull together our coal communities across the Powder River Basin, get us all working together collaboratively and moving in the right direction, or at least a direction. So I will welcome all of you, but let's give an applause for Dr. Phillips for pulling us all together.
Okay, thank you to our speakers this morning so far. We're going to start in on our update presentations here. Let's see. There we go. Okay, so I am going to give an introduction to the CORSIUM initiative and the Powder River Basin CORSIUM project specifically. Okay, this project is funded by the U.S. Department of Energy. And this acknowledgement and disclaimer does apply to all of the talks that you'll hear this morning. So this disclaimer just states that all of the views and opinions that you hear are not necessarily those of the U.S. government. All right, so in addition to funding from the Department of Energy and the National Energy Technology Laboratory, this project is funded by the University of Wyoming School of Energy Resources, the Wyoming Energy Authority, and the Montana Bureau of Mines and Geology. Our core project partners include multiple entities from the University of Wyoming and within the School of Energy Resources, in addition to Battelle, BSI Energy Ventures, Campbell County, Wyoming, Alamos National, the Montana Bureau of Mines and Geology, Development Corporation, the Wyoming Energy Geological Survey. Grateful to our multiple industry development, regulatory officials, nonprofit organizations, and academic institutions who are supporting this project. As I said, this is a Department of Energy funded initiative. CORSIUM stands for critical minerals. Carbon ore is coal byproducts, coal waste streams, coal ash, and rare earth elements in detail in a moment. But the Department of Energy funds 13 of these projects across the country, and they are basin-focused projects focused on coal and coal byproducts, but all potential critical mineral feedstocks that could possibly contribute to basin-wide economics are being considered in these projects. So we are there in Region 7 on this map. And the objective of the CORSIUM projects is to catalyze basin-wide economic growth and job creation or a value chain. So critical minerals are defined as non-minerals and mineral materials, essential economic and national security of the United States. They serve an essential function in the manufacturing of a product, the absence of which would have significant consequences for the economy or national security of the country, and they have a supply chain that's vulnerable to disruption. The U.S. Geological Survey released a updated list of critical minerals in 2022. They are tasked with updating that list every 3 years. So that includes 50 critical minerals, most of which are individual chemical elements. And the rare earth elements are part of the critical mineral list. So they are a subset of critical minerals. Those are highlighted in red on the lower row of the periodic table there. And also scandium and yttrium are commonly grouped with the rare earth elements because they behave similarly. They have similar chemical behaviors. So here we have two criticality matrices for critical minerals. Is a modification of the U.S. Geological Survey criticality matrix, and that plots likelihood of foreign supply disruption to vulnerability of U.S. manufacturing supply disruption. And that has been modified by the Wyoming State Geological Survey to plot promising and current critical minerals in Wyoming itself. On your right is a criticality matrix from the Department of Energy. So the Department of Energy has a separate list of critical minerals, which is very similar to the USGS list, but with more of a focus on the importance to energy technology. So I'll note here that you may be hearing during the presentations today about conventional and unconventional critical mineral deposits. The USGS is largely feedstocks, so those would in general be deposits like the Bear Lodge deposit in Northeast Wyoming. The Department of Energy is largely focused on unconventional critical mineral deposits, so coal and coal byproducts are part of that. The Department of Energy has recently announced its ambitions to dramatically increase the production of critical minerals from domestic sources, from unconventional sources by 2035. So as most of you know, the demand for critical minerals is high and increasing. Critical minerals are used in many energy technologies, defense-related products, consumer products that we use every day. So the plot on the left here is from the International Energy Agency, and I'll just highlight here that within a single electric vehicle, the requirements for cobalt are about 15 kilograms. So that's a lot of cobalt that goes into a single electric vehicle. Other offshore wind, onshore wind, solar and nuclear also require significant volumes of critical minerals. And domestic critical mineral extraction and processing is still very limited. As you can see, some key elements and minerals, the majority of cobalt is produced in the Democratic Republic of the Congo, which raises concerns for fair labor and environmental standards. The majority of graphite and rare earth elements are still extracted from China. And on the right, you'll see that China really dominates the processing of these key critical minerals. So this concern over the lack of domestic extraction and processing is compounded by the fact that we have a complex supply chain for critical minerals. Here is shown the rare earth element supply chain, which includes upstream exploration and midstream processing and separation step, and downstream manufacturing. So for rare earth elements need to be separated from each other, and they behave very similar. They have similar chemical behaviors. So in addition to critical minerals, the Corsium projects are looking at coal to products research, and Trina Pfeiffer will be talking about this later this morning. But coal to products, that involves high value products like carbon fibers, as well as high volume products like building materials. And Trina's group is working hard on high volume uses for Powder River Basin coal. So that brings us to the Powder River Basin. And I know everyone in this room is well aware of these facts here, but I just want to highlight, you know, some of the assets that the Powder River Basin has. More than 40% of the coal produced in the U.S. comes from the Powder River Basin. The original coal resource in the basin is huge, estimated at 1.16 trillion short tons. Powder River Basin coal is mined at the surface from thick coal seams, improving economics. And Powder River Basin coal is shipped to power plants in dozens of states. In addition to coal mines, the Powder River Basin has the Bear Lodge conventional rare earth element deposit, as well as numerous other energy industries. And I think the most important point here is that the Powder River Basin has this robust energy infrastructure. We have a highly trained workforce in energy and technology, engaged stakeholders, as evidenced here today, and abundant legacy data. So this all really benefits these projects. So we're looking to leverage those assets in the Powder River Basin for the Powder River Basin CORSIUM project. Our overall project objective is to address all aspects of the CORSIUM supply chain to promote economic growth and workforce development in the basin. We're working on a strategic plan, which will be built out in the final stages of this phase of the project. And really, again, looking to make sure we're bringing together this network of committed stakeholders. This project began in September of 2021 and will end in August of 2024. So we are nearing the end of the phase one of the CORSIUM project. And when I wrap up this morning's talks, I'll talk a little bit more about the path forward and potential additional funding in this area. So this morning, we will be hearing from a number of people that are looking at these different areas of focus within the CORSIUM project. So each of these projects is focused on kind of these 6 main areas, basin-wide assessments of CORSIUM resources. So really understanding from a geologic perspective, what is the critical mineral resource in the basin? Assessments for reuse of waste streams. Are there waste streams available that could be potential sources for critical minerals? Assessing the infrastructure, industries, and businesses that already exist in the basin and how those can be leveraged for the build out of critical minerals and carbon ore supply chains. Looking at technologies and technology development chain, and then stakeholder outreach, education, workforce development, and environmental justice. I will touch later on strategies for technology innovation centers, because that's what we're really thinking about building out in the final stages of this phase of the project. So this is a very broad scope to this project, as you can see. But like I said, this morning, we'll be stepping through each of these areas of focus with our update talks. So with that, I am going to pass it on to Tyler Brown, who will give an update on resource assessment and geologic modeling.
Hello all, I'm Tyler Brown. I'm a research professional at the School of Energy Resources at the University of Wyoming. I want to thank you all for the opportunity today to talk about some of the excellent work that the resource geology team has been doing on the Powder River Basin resource assessment and some of the early models that we've been working on. So, as I mentioned, I am a part of a team. I'm a relatively new addition to the School of Energy Resources. I'm lucky enough to be able to work on and build some of the work that the School of Energy Resources has been working on for years now. Here's the list of team members that have been working on that resource assessment. And then we have a long list of teammates and collaborators, industry partners, state surveys from Wyoming, Montana Bureau of Mines and Geology, USGS, national labs. So I want to emphasize a special thank you to 3 of our industry partners that have been invaluable in the pursuit of data and understanding on this resource assessment. So, jump to. All right, Aaron, our slide, 3 main components that I want you to take home from this talk are: there is an existing demand for rare earths and critical elements. We in the Powder River Basin core sand project and all of the core sand projects nationwide are building the framework from with understanding unconventional resources. And this process is iterative. We are working, we are continually getting new data, updating understanding of processes, building out the models. It is an iterative process. So first, the demand. And Dr. Phillips did an excellent job of summarizing the demand that exists. These are some plots that you can see if you look at any press clippings or whatnot. This graph on the left, we have gigatons of raw materials on the left. We have time on the right. Time increases towards the right. As we can see, each of these raw materials were focused on yellow and blue. These are the minerals, both metallic and non-metallic minerals. Through history up until the relative present day, we have had an increase in those raw material demand. The projections for the future show an exponential increase in demand of those materials. The plot at the right is intentionally illegible. You're not supposed to be able to read it, okay? The reason I wanted to show you this, though, is we have a list of mineral commodities on the left, and we have the reliance on importation that the U.S. is. As you can see, 0% to 100% on the right. The U.S. is 100% reliant on the importation of several minerals and well more than 50% import reliant on other minerals. So there is a demand. So what makes these elements or these minerals critical? Easy explanation is they are susceptible to disruptions in the supply chain. That is the big issue. The periodic table of elements, as you can see here, everything highlighted in green is a critical element. Red is a subset of green, specifically rare earth elements. They are going to be what I focus on primarily over the course of the talk today. And rare earth elements, I want to draw your attention to two different ways to plot. You can see on the pie chart at the top right, most of the production is occupied by the red shape. If you look at the plot of production through most of the production and currently within the red shape, red equals China. So we're reliant upon China for importation. This need for critical minerals led to two main initiatives. One, Earth MRI project is sponsored by the USGS and the Department of the Interior, focusing on conventional sources of critical minerals and rare earth elements. And then we have what we'll be talking about today, the Core Sand project, and that is focused on basin scale and obtaining rare earths and critical minerals from unconventional resources. So we have a Department of Energy demand of over half of the critical minerals demanded by the US will need to be supplied resources by 2030 table. Half of that should be sourced from unconventional resources. So now the framework that we are building, map the US with all of the core sand projects, Powder River Basin area, and we have a magnified version of that on a GIS map. Okay, so if you ever look at a press clipping or some of the publications from the USGS in years past, they will typically show you the salmon outline. That is the traditional sedimentary basin, most of the traditional sedimentary basin that was sized for coals. We've expanded the area of interest to include the adjacent highlands. And just so you know, this area is ever expanding. All right, so resource assessment. Resource is anything that might be potentially in the potential for undiscovered mineral deposits and develop a plan moving forward. Resource assessment is dependent on three foundational components. One is a descriptive reporting of the geological system. Two is estimating the volumes of the resource that might be present by tonnage and grading estimates. Okay, so that's chemistry of these materials. And then the third is we estimate the potential for undiscovered resources. So part of that first component, the geological description, requires an assessment of the existing data, or what we call legacy data. So this is showing data sources that were cultivated by the United States Geological Survey. At left, we have the Powder River Basin, sedimentary basin outline. Each of these very small red points represents a spot where we have obtained or put a hole in the ground, a drill hole. When we drill, we get two main categories of data. We can get the rocks that were in the subsurface, and we can get wireline logs. If you have a bunch of different holes in the ground, you can start to correlate physical signatures or rock types over an area and generate what's known as a geological cross-section in the subsurface. If you have many holes, such as we have here, then you can start to get an understanding of the three-dimensional distribution of individual coal seams. And you can get volume estimates, tonnage estimates, and we can determine the amount of coal that's in place. This is an exceptionally useful data set that we have if we are looking at the Powder River Basin coals as an entire ore body for rare earth metals, rare earth elements, and critical minerals. So exceptionally useful. At right, I have that plot that you'll see several times today. And if you squint, you can see really tiny blue dots. Those tiny blue dots represent what is known as coal holes that were plugged into the ground. Core was collected and some quality data on coals were assessed. You got some geochemical information. This was done since the 1970s, so there is variable quality in the coal qual data. Plus, we see that it's not everywhere. Through looking at this data, we realized that we needed better data with high resolution, what we call high resolution sampling. That means we know the X and Y coordinates, the lat long where the sample is. We know the Z depth. We're able to correlate the stratigraphy. We're getting geophysical data, and then we can do rigorous sampling and measurement of chemistry within those samples. So we need high resolution sampling. That's where we became very reliant upon the generosity of some of our industry partners and state surveys. All right. So when we obtain high resolution sampling for analysis, it's a multi-step workflow. Obtain core and geophysical logs. We then take that core, start analyzing it in the lab, get geochemistry data on those samples, and then we can use both the geophysical and geochemistry data to start to get after what process is happening for enriching rare earths and critical minerals in these coal feedstocks. Once we understand process, then we can generate a model. And those models can be on the basin scale on the left, the national scale, or even the mine scale. So that brings us to the next point, that this is an iterative process. We can go through this workflow, and by the time we get here, we notice that we have data gaps. We notice that we have some trends that we didn't expect, which make us refine the process, which makes us start all the way back over at point one. It's an iterative process. The final model will only improve as we go through successive iterations. So, let's skip to, okay. Now, let's talk about some actual data. Descriptive reporting part and the grade, the geochemistry of these data sources. So, the data that we have been building, we have 1,400 plus data points for coals and associated sediments in the Powder River Basin. These include the legacy data, plus the new data that we have been collecting, plus industry donations. Ryan Davison will be talking about some of the work that Montana Bureau of Mines and Geology has done on coals in the Montana portion of the Powder River Basin. There is recent work done by Ramaco and the National Energy Technology Laboratory at the Brook Mine. We are building out the data sources. Also want to acknowledge that we have gotten almost 400 feet of new core in the past couple months. We are going to go through rigorous sampling of that new core, and special thank you to the operators of those locations where we obtained core. All right, so that was coal and associated sediments. We also have the unconventional feedstocks that Dr. Phillips mentioned. Bottom and fly ash. This is one of those waste streams, and Dr. Lily Jackson will be talking a lot about the waste streams in a presentation here in a little bit. But we have different volumes and tonnage estimates for resources within this air lodge and the Halleck Creek sources earlier. And then we've also taken note of phosphorus and heavy mineral sandstones that the USGS started to study a few years ago. All right, so my favorite part, the actual data. At left, we have a plot of rare earth concentrations that are normalized, okay? So on the x-axis, you have all of the rare earths. The y-axis is essentially a normalization to upper continental crust concentrations. And we can plot the concentration relative to the upper continental crust. That equals 1. So as we can see, all of the Powder River Basin coals have elevated rare earths compared to upper continental crust. Now, if we start to group those profiles by area, we can, so this salmon color at the top, there are 4 lines here, are representative of data that we have central Powder River Basin. The blue is what we have from a few samples in the north of the Powder River Basin, or central northwestern part of the Powder River Basin. Each of these profiles, as you can see, slightly different in their overall geometry, especially mustard color, which also comes from the central Powder River. The fundamental take-home point from this is that these different profiles might indicate a difference in process. So we have to understand process based upon these patterns. That was on the basin scale. Now, this plot is showing the coal from the surface on the y-axis, and then total rare earth concentration on the x-axis. The colored blocks represent individual coal seams, named coal seams. And I should thank Peabody Coal because they helped us obtain these 2 data points right here. If we look at these down holograms, then we can see that there is elevated concentrated near the tops and bottoms of these coal seams. That is true of these 2 Peabody coal, okay? That is relatively true GS coal, and this is plot over here is within 1. You see both the bounding enrichments and enrichments. So this is data points. We need to expand the data and see if this is true all over the basin. And also notice that the colors are different. They're different coal seams. Is this true of every single coal seam within the basin as well? All right. So this work, this observation that coals had enrichment near the bounding edges made us want to look at the bounding sediments. So the non-coal sediments that are above and below these coal seams and within these coal seams. And this represents some work that's being done by Sophie Stewart for her PhD at the University of Wyoming. She started investigating these clay seams and looking at the mineralogy that might be associated with these clay seams. All right. So all of this towards estimating the potential for undiscovered resources. And this gets to some of the work that our partners at Los Alamos National Lab are doing. So we've been through this workflow. This is something you've seen multiple times already. What Los Alamos is doing is they're taking an entire suite of elements and then using some advanced modeling element. If there's an increase in the concentration of one element, is that associated with an increase in the concentration of interest? They're doing this not only for geochemistry, need to incorporate geophysical data as well to see if there are signals, geophysics that might be related to elevated elements. They can then take these signals and apply it spatially and predict areas where the paucity of data to then say, hey, we need here and see if there actually is valuable concentrations. So, to take away, we know there's existing demand. We saw that from the have a need, 2035, half of the domestic source of critical minerals from unconventional feedstocks. We are currently building the framework, okay, and it's an iterative process. But I want you to notice again here, we need buy-in from everybody. We need all stakeholders to take our understanding of the geological process concentration. It's going to give us a better understanding.
We have time for one question from Tyler, for Tyler.
I'm here all day. I got a question.
I have a question, but I just might know the answer anyways. Where's the biggest data hole do you feel right now with respect to trying to get that iterative process cleaned up?
Really want to understand. Can everybody hear me? Okay. We really want to understand more of the northwestern part of the Powder River Basin and more of the northeastern part of the Powder River Basin. And Ryan Davison will be talking about a lot of work that just was completed about the work in Montana. And we're hoping to build upon that as we move forward.
Next, we have Ryan Davison from the Montana Bureau of Mines and Geology, and he will be speaking about Montana-focused resource assessments.
Okay, so a little bit about me before we get started. Background, I used to be an archaeologist, which is awesome. Then I went into geology, worked in oil and gas for about 10 years. I forgot to put it on here, but I also worked at Stillwater at the mine. So I was a mine geologist for a little while. Then I've been at the Montana Bureau of Mines and Geology for almost 2 years now. My current projects are what I'm going to talk about: assessment of rare earths in Montana coal, investigation of geothermal potential in Montana. I also worked with Erin and her team on Core CM, and then a Core CM project in North Dakota. So everything kind of overlaps. Just some fun stuff. So I'm really into dinosaurs. There's a great park outside of Moab that has life-size recreations of dinosaurs, so you too can create a picture of you running from a T-Rex. This is my home in Red Lodge, which is gorgeous. I always go to Yellowstone over here, and some of my hobbies are travel. So my favorite city, Tokyo, and then there's Greenland over on the right. And some of my hobbies are also hunting, filmmaking, and in general, beer. Okay, so I love Eastern Montana. Here's some visual pictures for your pleasure. These are some from my recent trip. Just like gorgeous scenery in my opinion. But this is what I get to do when I go look for coal. So it's a lot of fun. Okay, so in summary, or for my intro, so what I'm going to talk about today is Montana coal and rare earth elements. Sampling from year one. So this is the stuff I can release. This is kind of general, but I learned a lot from this project over the course of a year. So there is good news going into next year. I'll talk about some of my PX, RF analysis, outcrop weathering, methods of enrichment, and then some conclusions. This kind of keeps me going. This was a funny quote that Paul told me, so I try to prove him wrong as much as I can. Okay, so Montana coal, just briefly, we have a lot of coal. So it basically underlies about 35% of the state. So you can kind of see east to west, we have a lot of coal, but that's not representative of all the coal. That's just basically the Fort Union formation. There's a lot more coal in kind of like the Cretaceous, for example, and other formations that aren't on here, but the Fort Union just has a bulk of the coal that we mine. As the largest demonstrated reserve base, so 103 active strip mines in the state and 1 underground. Most produced coal is sent to other states. We do keep some. Signal Peak, I still think, ships to Japan via Canada, not through Washington. And then right now, coal strip is basically the power plant. It's pretty substantial now that I'm looking at geothermal potential. Okay, so my main project, but Army Research Laboratory. I'm a part of a task to look at any coal sediments in Montana. So what it is the assessment of coal and related sediments in Montana. It's not really specific on what. It's never been really done. There's been a ton of coal studies, probably going back almost 100 years, but no one's really looked at rare earths in coal specifically. So I'm one of 16 tasks. Some other tasks are more looking at and other rare earth potential. What it's not is how to extract rare earths. So those, I'm assuming everyone knows, but just in case. So REY is rare earths, but I'm not including scandium. So in some of the coal studies, they'll do that. So it's focused on how to extract. It's not focused on how to extract rare earths from coal and coal ash. I'm not really focused on coal mines, although that's part of what I do as well. And then my job as a geologist is basically to tell you where the rare earths are, but I'm not necessarily concerned about trying to make it economic. Okay, so for season 1, I kind of, real quick, I imported a bunch of maps all in and started looking at outcrop points. I should also point out for this, I'd never done any coal work, so it was a big learning curve. In general, coal call was not really useful for this study because a lot of the data points were usually in one part of the coal, and I think as others have already mentioned that rare earths kind of tend to either be at the base or the top of coals. So a single data point for a coal isn't necessarily useful. It just kind of tells you that there are rare earths. And then a small percentage of historic data. So the coal qual has full analysis for rare earths, but not a lot of help. And then, so I've collected almost 400 samples so far, focusing on mostly the east side of the state, just because it's a good starting point, and that's coal production historically. Good promise. So as I mentioned, Fort Union formation was my focus, and then these part of the Fort Union separated out, and then I also looked at. Okay, so assay results. So the Department of Energy has a 300 parts per million cutoff for economic. I don't know, even though it's fraught with problems, but it's a good number to kind of. So you can kind of, the highest was about 5 results, and then it kind of drops off from there. And when I throw all of the data up there, so this is a chondrite normalized, and you can kind of see everything falls in line with this. So sorry, we have light one into heavy rare earths on this side. What you want is more or less, not a complete, well, you want the graph to ideally go the other direction because heavies are worth more, but this is really good compared. I don't have a graph of some of the other rare earth deposits, but some of them start, way up here and then drop down. So this is good. And then comparing it to the world in the US, more or less tracks, which is good. So I also found that Tongue River coals and all the 4, that's ridiculous, but the rare earths don't really pack that much of a punch. And it's, admittedly, so far what I've tested is mostly base, middle, and then top of these coals. It's hard to get any overlying layering just because mine operations, etc. But my goal is to sample a little bit more at the mines. But you can kind of see the samples average 71 parts per million, maximum is 162, so a little low, unfortunately. But more to come. So let's see. This is just kind of split into images. So let's see. So 62.1 is the average parts per million, rare earth parts per million in coal. So you can see that this is non-coal, or this is coal only. This is non-coal. So for the coal, 50%, almost 50% of, and then a quarter basically you're over 100. These aren't numbers I was kind of hoping for, but I'll show you some reason for hope. Okay. I also did some, check my time. Start the timer, that's good. Okay. This is Powder River Basin. Okay, so I've only been out here once. Well, I've been to the mines a couple times, but saying some of these outcrops, I've been there once. So this is definitely not all the samples I have total. So I'm halfway through year 2, so I've already been back. But looking at it, maximum 400, it's kind of getting there or so. Been back out to some of these elevated numbers here and gotten some better numbers. So there's lots to investigate. And then, so some promising coals listed here, Pawnee, Canyon, Knobloch. Some complications with the powder though is the ground cover is just atrocious, especially when it's August. You know, it's grass up to here. It's impossible to hike around, so that's been an issue. And then depletion of rare earths and outcrop. So this was a big, you know, I always say unfortunate, but it's not an unfortunate lesson. It's just a lesson that I learned that I'm going to talk about here more. And then Forest Service. I won't talk more about that. Okay. This is just another way to kind of look at some stuff here. So again, I didn't want to put the entire graph of all my samples up here, but even with this smaller graph, so this is rare earths greater than 200 parts per million. You can kind of see it's still trending. So this is top of coal, bottom of coal, below bottom of coal, above top of coal, and then whole coal. And you can still see it's kind of still trending even in a small sample amount towards base of coal. And so that's kind of been a trend I've noticed. And with coal, not only coal, but also all sediments. So sometimes you'll get clay layers beneath or above that are usually quite high in rare earths. Okay, so I want to talk about this real quick too. So the advantage of a PXRF is, you know, X-ray fluorescence. It's in a lab, you can do it very well and you get great results. In the field, it would be nice if you could just scan something and be, oh, this has this parts per million. We're not quite there yet. Technology is not quite there yet, but it's worth investigating because it can save a lot of time on samples and analysis. So I've been trying, this is one of the things I've been trying to get into. Some things about it though, cost 40 grand for one of these. Our Butte model was missing bolts and couldn't connect to the software. North Dakota didn't have a battery charger and refused to pay, so it took like 7 months. It's useless for direct detecting of rare earths and coal. And then, but we know that yttrium prefers heavy rare earths, and then you can kind of calculate your lights from the heavies. So Y, heart, H. But so I tested this Y ICP data with HREs, and you get kind of a nice, you know, correlation here. Not so much when I try to compare the Y lab tested results with my XRF, you know, not great. So is there things we can do? Yeah. It's a learning curve, like I said. I have been able to improve this by doing some different methods before I sample. Weathering is also an issue, and I'll talk about that next. But essentially, you can take some ratios and come up with a number of 48 parts per million. So when I'm in the field, it's really nice when I hit above 48, and then I know I'm on a hot spot and I can kind of dig in. So outcrop weathering. Maybe he just went to sleep. All right. I'll just keep talking. Okay, here we go. So I basically copied everyone else when I started this study, especially North Dakota and states like Kentucky, who are way ahead of us in rare earth testing. And so I found out that further than, you know, I have been a foot and a half usually. I wonder if I could get better. This graph over here, so basically that graph over there was from year one, started at the very end, and got some, you know, pretty usual results, and especially, you know, being, you know, over 200 parts per million more by a little bit more. It was pretty depressing because, you know, I wish I had done that the whole time. But in year two, found that this is indeed a factor. So I've been using this core barrel to dealer sample. So it's, you know, like I was talking to Aaron last night, it really says something about how fast these might be leaching out from the coal that's exposed, which in some cases might be really quick because a lot of these are taken from road cuts. How am I doing on time? Okay, I'll rush through this. Anyway, so another big question I'm trying to look at is just how rare earths get into coal. So this is just a highlight of all the ways that it can happen. There's lots of ideas on this. Nobody's quite sure on all of it. But one of the goals, or at least be able to recognize when deposits might contain significant enrichment of rare earths. So I won't go into all this, but if you haven't read it, there's a great paper, Edward Murphy and Levi Moxness from North. They looked at this Bear Den formation, elevated earths that are pretty crazy. I think the highest, maybe in the US, for upwards to 1,800 parts per million, above 2,000 in some of the clays, which is pretty incredible. They were leached from the overlying soil and then captured in the coals down below. So anyway, these are just looking at for Montana. And then finally, I'll just say this has nothing to do with much, but it's pretty cool. So in my job, I also get to run the coolest one, of course, if you're into dinosaurs, is the KPG ash layer that represents when all the dinosaurs went bye-bye. So that's been a lot of fun. And yeah, so final thoughts, a lot to learn. Highest one for year one was 501, but keep in mind that's 8 times the US average. PRB still has lots of potential. I'll have year 2 results in about 4 or 5 months. Weathering effects results, year 2 are spent collecting and focus areas on my research. There I am. All right.
Thanks, Ryan. I think we're going to move on in the interest of time here. So next we have Lily Jackson from the University of Wyoming School of Energy Resources, and Lily will be talking about the waste stream assessment.
Hello, everyone. Hopefully the slides work. Otherwise, I'll just have to describe what the slides would look like. All right, it's nice to be in Montana. I've only been here a couple times, actually, usually looking at rocks. So I'm Dr. Lily Jackson. I'm a research scientist for the Center of Economic Geology Research at the University of Wyoming. And I've been working on looking at waste streams in the Powder River Basin. And along with some of my colleagues also listed here. You've seen this a couple times. Powder River Basin, most of the activities are related to the extraction industry or energy industry. As you are well aware, 40% of all US coal comes from the Powder River Basin. I think the numbers for coal power plants, I think that's like nine coal-fired power plants that are operational and 16 mines or something like that. So a lot of activities around coal. Also bentonite mining, uranium mining, and a lot of oil and gas activities, production, separating, and processing. And so we want to take a look. They have waste streams that could potentially be useful or beneficial for the critical mineral supply chain. So we've been looking at this, trying to look at this waste stream assessment as sort of these 3 categories, being waste as a direct feedstock of critical minerals, repurposing of waste for these techniques for processing are still in development currently, and then utilizing existing waste in critical mineral separations. And so I'll focus on mostly the first and third sort of bucket, and we'll get right into it. So I want to show you some data from coal-associated materials and our waste, or could be considered waste. So we have clinker, so that's those ancient coal seams that have been on and sort of they melt the rock and then form this sort of glassy material. Realized from going to some of the mines that it's called scoria locally. So same thing. Scoria is actually a volcanic. So it's not technically scoria, but it makes sense called scoria because after burning, it's almost like a volcanic rock. Okay, so anyhow, so for clinker samples, we have a limited data set. There's 10 samples of clinker, but like coal ash and coal itself, as we've heard, we have seen that clinker is elevated relative to average upper continental crust. Was 287 parts per million. There's one sample that's elevated than the others that's kind of pulling that average up a bit. But again, limited data set, so it would be interesting to look at clinker in more detail. All right, and then over here is a graph of fly ash as well as bottom ash. This is previous data that was published in 2022, but showing that the fly ash, even after the coal has been spent, it is still elevated in rare earth elements. And so interesting to us, and this is plot to upper continental crustal values in previous talks. And the average from 117 samples was 317 parts per million. So that's promising. And all right, we're starting to look at legacy mine features in the Powder River Basin. And so I recently made this map where I've plotted up all the legacy mine features that I could find from the US type land ownership. And there's a lot of these mine features are clay pits and gravel pits, probably for roads and such. But there are quite a number of prospect pits, uranium mines, and mine shafts that not really sure what those are. But we're interested in taking a deeper look at some of these legacy mine features to see if there might be anything there that we can use from the waste stream side, tailing piles or such. Okay, for the rest of this talk, I am going to be focusing on produced water, water that is co-produced from oil and gas and coal bed methane. And so here I'm showing you a series of maps showing oil, water, and gas production for the year 2022. Yeah, one thing that you'll notice probably right away is that there's a lot going on in Wyoming, but not a lot in Montana. And I did pull this data from the Wyoming and Montana Oil and Gas Conservation Commissions, respectively. So if there's data that should be there that's not there, please let me know, because I wasn't able to find it. There's a lot of oil and gas activity outside of this area, but in the Powder River Basin, respectively, it's mostly Wyoming. So what I want to sort of emphasize is that there's a lot of water that is co-produced with oil and gas. And so these pie charts, the larger pie chart is 2022, and then the smaller one, just to take a broader look, is a multi-annual average from 2015 to 2022. And so as you can see, there's a lot of water that's co-produced with oil and gas. And so, so total fluids for 2022, of total fluids for 2022 that were produced, 86% of those fluids that's water. And so is this a potentially useful waste stream? So we're going to take a look at that. We can categorize this produced water into two buckets, being coal bed methane produced water and non-coal bed methane produced water. All right, first focusing on coal bed methane produced water specifically, which I am showing locations for production on these maps. And the location for coal bed methane production coincides with the thickest part of the Wyodak-Anderson coal seam. And so these pies that I'm showing here, again, the larger pie is 2022, smaller pie is the longer term multi-annual average. There was 42% of the produced water was from coal bed methane, 2022, and 58% from non-coal bed methane. So coal bed methane is contributing a lot to this water totals. Now, that's actually kind of interesting because, as it turns out, coal bed methane produced water has very low total dissolved solids. It's actually really clean. It's quite surprising. And so I was able to locate 695 coal bed methane water analyses in the Powder River Basin. And of those 695, 77% of them had total dissolved solids lower than 1,500 milligrams per liter, which is the same thing as ppm. So that's actually very low. I'm not the first one that noticed this. This is a figure from Bridget Scanlon and co-authors in 2020. And she found that the Powder River Basin coal bed methane co-produced water had some of the lowest total dissolved solids of any of the formations that they were looking at. And this was a nationwide study. And so Powder River Basin coal bed methane co-produced water is very clean. And especially if we compare it to other formations, deeper formations. And so I guess the point here is that coal bed methane water is sort of low-hanging fruit for use in the critical mineral supply chain. It's easier to clean up, right? So of course we would have to take a deeper look at at exactly where that coal bed methane produced water is going. A lot of it is discharged out of the surface. Maybe some of it is used for irrigation, but definitely low-hanging fruit for that. All right. Now we are moving on to non-coal bed methane co-produced water, and we're going to look at just regular oil and gas produced water, and I want to talk about lithium. Okay, so this map over here is showing the 588 produced water analyses that I was able to find in the Powder River Basin with non-zero lithium values. And there were only 8 of them were at or above 50 parts per million. And everything else was below. What do we have? 93 data points between 10 and 49, and then 488. So what's up with these where, hey, maybe that's something that's interesting to look. And if we look deeper into those, we see that most of these, they're legacy data, and they have various sampling methods. Be advantageous to resample areas and see if some of these values are true, right? So some are enormously high. And if that is good data, then that's interesting, but it definitely is worth. Oh, interesting. Okay, so there's also 10 samples of water that have rare earth analyses, and they're all sort of clustered around here on the map. This is a plot of the rare earths from the waters. Now, the scale is interesting. It's relative to North American shale composite times 10 to the 6. Essentially, the axis is inflated enormously because these are really low values. They're in the parts per trillion. And so in summary, for the produced water for lithium and rare earth elements as a direct feedstock, it's not looking too promising, but I will come back to that because I have some ideas about this. Disposal volumes for produced water. And so this brown part here is disposal volumes, 2022, and then longer term. So disposal volumes, injection volumes, but I think what's more interesting is the missing part of the pie, which is the volumes that are on record anyhow, not injected or disposed. So where is that water, right? Where is that going? Well, turns out evaporation and solidification of produced water is one of the most common water treatment methods in the Powder River Basin. And so if you spend a lot of time in the Powder River Basin, or maybe you fly over it, you see a lot of these settling ponds, and a lot of them are holding ponds, and that water will be reused for fracking. But a lot of this water is simply evaporated, and so natural evaporative enrichment will concentrate any minerals that are in the water. And so this is, in my opinion, something that would be very interesting to look into for things like lithium and other minerals that are on the critical minerals list. So I can't find any data that have any data for the United States for sampling of these produced water, sampling of these settling ponds for critical minerals. If anybody here knows of any data, please tell me. I'm looking for case studies, and I'm very interested in sampling these because in theory, they should be naturally enriched. I did find one publication. This is not from the US, this is from the Arabian Peninsula. And this team sampled a series of settling ponds. And so in this case study, they have quite a few settling ponds, and they found between their first and then their final pond a 470% enrichment in lithium as well as 200% enrichment of beryllium and 580% magnesium enrichment. So I think that's interesting. All right. Conclusions. So we looked at some coal associated materials and byproducts and found that clinker and fly ash, they're both elevated above average upper crustal values. And then we're interested in looking deeper into some of these legacy mine features. Produced water, a lot of water is co-produced with oil and gas in the Powder River Basin. 42% of that water is from coal bed methane. Coal bed methane has very low total dissolved solids. And so a potential strategy could be targeting coal bed methane produced water for use in critical minerals processing. Further, produced water from the Powder River Basin isn't promising as a direct feedstock, so straight out of the ground, but potential evaporative enrichment of minerals in produced water settling ponds warrants further inquiry. And a strategy could be for operators to analyze water during production and find those formations that have moderate values, say 20 parts per million, and then selectively impound that water for evaporative enrichment. And then finally, I would love to hear from folks. So catch me. I think we have a break after my talk, so that's perfect. Catch me on the break or catch me. I am very interested to hear if there's other waste streams that I'm not thinking about. So is there any other things happening in the Powder River Basin that we should be looking into for waste streams? Thank you.
Thank you, Lily. All right, we're going to start again here with some presentations on the middle part of the supply chain around technologies being developed for critical minerals separation and extraction, as well as some carbon ore to products research. So first we have Morgan Evans, who's the lead environmental specialist at Battelle.
Thanks, Erin. I'm really excited to talk to everyone today about the first technology assessment, which is focused on extraction and processing of critical minerals from Powder River Basin based feedstocks. So really the objective from the outset was to evaluate technology gaps in processes for extracting, separating, and purifying rare earths and critical minerals from potential feedstock materials specific to the Powder River Basin. Essentially throughout this presentation, we're going to of those processes for extraction, separation, and purification actually entail. And then we'll go into some of the feedstocks that we investigated for this particular assessment. Erin did a great covering this before. And as you'll notice, there's some kind of different terminology, the unit operations involved in the supply chain for extraction and processing of critical minerals. This overview is pretty specific to rare earths, although several of the processes can be analogous for other minerals in their industries. So when we're looking at kind of unconventional resources in particular, obviously we're kind of skipping the traditional ore-based mining processes. But the initial step in most rare earth processes is beneficiation. So I have that called out here as kind of a separate operation. There's several different types of beneficiation processes. This typically converts a desired material at a 20 to 30% content to 80+% in cases, and we get tailings as a waste product during beneficiation. And there are processes such as gravity or magnetic separations, froth flotation, and many others that have been used in the industry for a long time. Feedstocks such as ion exchange clays or mineral sands require little to no beneficiation, but where you look at things like hard rock minerals, they typically require beneficiation processes. When we're looking at things like extraction or upgrading, separations, alloying, we're going to go into those in a little more detail on the next few slides. So as far as extraction and upgrading goes, this is typically performed either on site or after beneficiation to a processing facility. And this step, we typically have digestion and removal of different impurities that are very common to the rare earth industry, some of them being calcium, magnesium, aluminum. So a lot of transition metal species, other one, and then we have typically the radioactive elements that of some of these processes. So typically this extraction and upgrading step, the goal is to get the feedstock to a 70 to 95% purity rare earth, typically a pregnant leach solution or a leachate. And you'll also hear the term cracking, and that specifically refers to removal of the radioactive material within the feedstock to kind of have that as a separate waste stream. So traditionally, extraction and upgrading, there's a lot of different digestion techniques out there using both acids and bases that can help kind of break open the matrix that you're working with. Solvent extraction and ion exchange can be used, especially for impurity. Precipitation methods can be used, again, to kind of get out things like iron. There are emerging methods that are coming out of a lot of different places right now. So a lot of kind of work is going on in the biological space to do targeted separations and purification to get out impurities, purify your rare earth stream. Related but kind of tangential to that are organic acids, which can either be biologically produced or chemically produced. And then there's some emerging techniques in flotation or some specific heating that are coming out of specific kind of academic institutions. So some of the main challenges with extraction and upgrading are that this is a very feedstock specific step. So when you look at a hard rock feedstock versus maybe even something like tailings or an aqueous feedstock, what you're going to do to get your feedstock to a semi-purified range is going to look very different. And impurity removal and waste disposal are always going to be challenges here at this step. And we also have to consider any processing steps needed kind of for the highest value rare earth products. So this step in and of itself can be very costly, but you're not getting your purified material out of it. You still have several steps after this before you can actually have a truly saleable product. So again, efficiency, cost, and environmental impact are kind of the names of the game with this step, but it is necessary to kind of move rare earths along the supply chain. In separations, I kind of have this as its own unit operation because it's so challenging and there's so much research going on in this space to separate the chemically similar lanthanides. So the goal here is to get individual 99+% purity rare earths or industry relevant blends such as neodymium and praseodymium together, because those are typically found together in. So in terms of technologies, the legacy technology is traditional solvent extract, the separations that you desire. There's a lot of supply chain dependencies. So the chemical extractants that are used in a lot of the processes are typically found overseas, manufactured by China and other nations. And so we're going to establish a domestic supply chain. We need to remove those dependencies. And then we see that precipitation is often used to further kind of remove some of the impurities here. So as I mentioned, there's a really big challenge just in how chemically similar these species are and getting them to separate in a way that's efficient and cost effective. And so we need to really consider efficiency and environmental impact when we're looking here. But as I mentioned, there's a lot of research going on in this area. So lots of different modifications to solvent extraction, different ion exchange and flotation methods. Biology has really emerged in this space at smaller scales, like at bench scale. And it'll be interesting to see if those can be scalable at an industrial kind of relevant scale. And there's a couple other different separation techniques that are emerging at the moment, but everything is pretty early stage as far as bench scale or very early pilot scale in those spaces. And then the final step before any kind of manufacturing and alloying is that this area doesn't get enough attention. This step where rare earths are reduced from or a chloride or an oxalate coming out of your processing to the elemental metal step, which is a necessary to alloying. So you have your ion going to a metal. Molten salt electrolysis and metallification are used for the heavies and the lights. Just to this is one of the most energy intensive steps of the enhancing chain. There's an extreme, concern over the environment because a lot of times these processes are being done in furnaces above 1,000 halide salts. And this is also the least mature of all processing areas in the US with very minimal domestic capabilities. So when you look at the supply chain and the figures Aaron showed earlier about different countries kind of dominating different parts of the supply chain, this part is almost 100% offshore. the R&D is very minimal compared to previous slides. So electrowinning and electrochemical methods for reducing the rare earths. There's unique challenges. Rare earths do not do well in aqueous solvents, so you have to work with water, which is always fun. Production using some different techniques like heat and hydrogen. So I think this is an area that is definitely needing some work. In terms of moving towards looking at how these technologies apply to the critical minerals in the Powder River Basin, our approach was to take the list of target feedstocks that the University of Wyoming had provided, then look at the potential critical minerals in conjunction with the resource assessment and waste stream teams. What technologies already exist to recover critical minerals from the given feedstock? What scales do those exist at? And then so we kind of have grouped the different feedstocks into advancement feedstocks that are on the list. So when we think about things like Bear Lodge, obviously that's very advanced technology. When we look at the, kind of coal and coal byproducts area, there's been a lot of investment and development of technologies for extraction of rare earths from those feedstocks. And then things like pegmatites, which might have considerable lithium, have adjacent industries with technology applicable to them. But there's several feedstocks that there really are not current platforms for technology for development. And maybe there's, some early stage technologies or adjacent technologies that could be applied to them. And that includes everything on this list here, from uranium roll fronts all the way to waste rock and tailings. And for the next few slides, I'll focus on just a handful of those that I think were worth highlighting. So in terms of coal and coal byproducts, we're looking at rare earths, cobalt, nickel, scandium as kind of the target critical minerals here. And I'll highlight quickly, there's a lot of technologies looking at coal and coal byproduct extraction, and many of them are worth mentioning, but I did not have the time to put them all on one slide. But I think that the National Energy Technology Laboratory's work is very directly applicable, as they've actually worked with Powder River Basin based coal ashes. So there's a lot of opportunities here, I think, as this audience is well aware of. Many tons of rare earth oxides could be produced from the 1 million tons of unused fly ash in the Powder River Basin. And the Powder River Basin coals have a really great kind of basis for extraction compared, which really reduces the costs associated with the processing. There are still questions around, coals versus some of the combustion byproducts. And then obviously, continued work that's going on with scaling commercialization and reducing environmental impact of processing specifically. The uranium roll fronts, I think, are a very exciting opportunity to consider during the in situ leach mining of uranium. Here's an example just roughly here of what that typically looks like. There's good evidence that the rare earths are likely leaching out of the ore body along with uranium, but not being currently recovered. And so there's an opportunity here for co-recovery of rare earths. Vanadium is another critical mineral that could potentially be extracted from this industry. And I think there's an added bonus that because industry operations are already active in the uranium mining industry, this is a really value-added product type of opportunity. There are some specific challenges where active mining operations with acidic enriching are required. So in the US, the majority of uranium mining is done with an alkaline leach, and we will not probably get rare earths with that method. But acidic leach, there's some good evidence that rare earths will accompany the uranium. There's going to be a lot of impurity removal to be considered here. So iron and aluminum are in the grams per liter range and may interfere with a lot of the extraction processes. And be, fairly expensive to try to get out of the way up front. I won't talk too much about produced water because Lily did such a great through that. But as she mentioned, the rare earths are fairly low in concentration, kind of standing up an industry on challenging, but there's some other critical minerals like lithium, chromium, vanadium, zirconium that may be worth looking into. And again, as mentioned, kind of this pH of these waters may also present some processing challenges. There were other processes developed for aqueous-based rare earths and critical mineral feedstocks like acid mine drainage, but because steps that are very inexpensive can be done to concentrate the feedstock, that's going to be a little more challenging with circumneutral pH fluid. But I think there's enormous potential here, as Lily highlighted, with the volume of produced water in the basin. And finally, I wanted to highlight bentonite clays in the area. Some really early research kind of looking at just not powder, but in Texas showed really high concentrations of rare earths in bentonite samples. And they did some early work showing that they think the rare earths are potentially in a monazite phosphate mineral phase. And there are some existing technologies to recover rare earth from monazite-based feedstocks already. So technologies already exist that could be tailored and kind of, adapted to this feedstock specifically. The bentonite deposits in Wyoming make up 70% of the world's known deposits. So again, I think there's incredible potential there. But I think there's, some work to be done in actually assessing the feasibility of this feedstock, as well as thinking about where rare earth processing would fit in the existing bentonite mining industry. So just to wrap up, I think the existing work that is, advancing with traditional based ores and coal and coal byproducts should continue, but that these alternative feedstocks need to be investigated as well. I'm very excited to see the resource assessment results to see, if they confirm or kind of deny some of the suspicions here about critical mineral potential, and then developing or adapting technologies from adjacent industries for some of these new feedstocks to figure out, impurity removal, kind of waste disposal, as well as most efficient and economic extraction. Thank you.
Thank you, Morgan. We are going to keep moving here to Trina Pfeiffer, who is the Director of the University of Wyoming School of Energy Resources Center for Carbon Capture and Conversion, and she'll be talking about carbon ore to products.
Okay, all right. Good morning, everybody. My name is Trina Pfeiffer, and I am the Director for the Center for Carbon Capture and Conversion. This is part of what we do at the School of Energy Resources in my area. So we are going to be talking about the carbon engineering program that both Aaron and Scott have previously just mentioned. Carbon engineering program, just to give you a background, was started in 2016. It has been funded. It was funded in 2016 by the Wyoming legislatures, and it is continuing to be funded by the Wyoming legislator. We were basically tasked with exploring non-thermal uses of coal to just see, okay, what else can we do with this wonderful product we have or resource we have. We had several projects that we started, and we have narrowed it down to 9 areas, or actually 12 areas of research. And we have 2 upstream processes that we work on right now. This is the 2024 update. We have solvent extraction, which is one thing that we are working on, and then pyrolysis, which is a fast flash pyrolysis, not a thermal pyrolysis. Flash pyrolysis is high temperature and very quick resonance. So not a slow burn, if you will. Anyway, we are also worked on 10 downstream products for commercialization. Our focus is taking the products, going into the lab, figuring out, okay, what's going on in the lab, and then doing a bench scale, pilot scale, and then eventually going to commercialization. That's our goal with these products. And so we have 3 main areas that we have narrowed the things down to. One is asphalt binder from coal. We are working in collaboration with Western Research Institute on this. Another area is building materials, and we have a project with the College of Engineering and Physical Sciences working on all things building materials. We have some products over there on the table. One of them is our bricks, which I'll talk about in a little bit. And then the last thing that we're working on, not the last thing, but one of the other things, which are high volume uses of coal, which is what our area is. Not to say we're not working on high value, but our focus on this talk is high volume. So is soil amendment, and I'm going to talk about that also. The other thing I wanted to point out is we are building a field demonstration plant for all the upstream processes, meaning the solvent extraction and the pyrolysis part of this project in Gillette, Wyoming. So carbon engineering flow chart here. Upstream areas here, solvent extraction and pyrolysis. The solvent extraction, we have that ilk. And then we also, out of the solvent extraction, are looking at polymers. So fillers, resins, coatings, that kind of thing. And then we also are looking down here for some building materials it with the solvent extraction. So it's the extract that comes off, and then there's also a solids portion, which is the residue, which is where we think the rare earth elements are. And so we're also doing processing on that as well to see what we can do to concentrate those. Okay. So now for pyrolysis, we have our soil amendment here, which I will talk about. Also building materials, that's where the bricks come from. And then we have a water membrane project that we're working on to pull out some impurities there. And then we also have, so just to give you an example or just an overview of the pyrolysis pilot plant, this is what it looks like here. We have a 2-stage pyrolysis project. We basically have a pre-pyrolysis step, and then we come down through here, this pyrolysis, the flash pyrolysis portion, which are and very low residence time here. And then we have a couple of condensers where we condense the gases and the tars, and then the drops out here. So this is our unit at the university. And the tar materials, and we're using them also to see what downstream and use that material. The whole point of the whole process is to take coal and use every molecule we can. And so that's the whole. So one of the things why carbon oil, I put carbon oil, I had to carbon oil because that's what we're doing here. So anyway, basically we have, hold on. We've got, okay, so I seem to be messing up. Okay, so we have the wall that we made here, okay? And one of the things that we have with our bricks is it's a Class A fire rating because we're using char, we're not using coal, okay? So, so everyone always asks, do they burn? It's like, no, they do not burn. So, and we sent the bricks to an outside lab, and they did all that testing, and it came back Class A fire rating, which is awesome. The bricks are half the weight of a traditional clay brick. We were very surprised that the VOC surprised to us. And the CO2 emissions are actually lower because we don't use a kiln to cure them. Cured outside or basically in the air. That's really cool. So, and these are that's some of the data that we, as far as the energy required to manufacture the clay brick here, that's the amount of clay brick, and then here's the amount of power needed to make a char brick. So there's a lot of really cool stuff. Built 2 buildings. One is our char brick house, and the other one is a clay brick house. They're right next to each other, and we have spent a year gathering data, which is what you're seeing there as far as the VOCs and that kind of thing, to compare real time for a whole year. And it turns out that in the summer, the char brick house is cooler than the clay brick house. So that's kind of also a positive. So come down to Laramie and I can show you around. That'd be cool. Another thing that we're using the char for is a soil amendment. We're doing some reclamation work at some of the mines in and around the Powder River Basin. The soil amendment is a carbon rich, basically it is carbon rich, and it has a couple things that it does as far as improving the soil. It has water retention capabilities, so you're not having to water as much, and we've got that data. I didn't put that on the slide, but I can talk to you about that afterwards if you want to know on how much water it can actually save. And then also it helps with nitrogen runoff, so that is also a good thing as far as fertilization, those types of things. So that's another one of the high volume products that we're making with the char. Okay, so now if you remember, there are 2 upstream processes. One is pyrolysis and the other one is solvent extraction. This is our solvent extraction pilot plant that we're building at the Lutz building. As you can see, it's a fairly, it's a little bit bigger than the pyrolysis unit. We have had a lot of demand for this because this particular plant is used in a lot of the research we're doing for the asphalt binder that we're making. So asphalt, if I don't know if you all know this, I didn't know this until I dived into the whole, a lot of different things to a lot of different people. Asphalt binder is the little gluey stuff. Asphalt itself is the binder plus all the aggregate and rock that you put in it. Okay. And then when you roll it out on the road, that's quote asphalt thing. Okay. So we are making the binder. Okay. We are making that sticky stuff. that you put together. Okay, this, right? So the current asphalt binder comes from oil refineries, and a lot of oil refineries are either retiring or they're being converted to biodiesel. So what's happening is the asphalt binder that people need in order to pave the roads is becoming scarce. The supply is becoming less and less and less, and the asphalt demand is actually growing at 3.6% per year. So we thought, hey, we have something. We have Powder River Basin coal, which if we paved the road or all the roads in the United States every year, we could do that for 900 years. Powder River Basin. So we thought, okay, what can we do? So US market asphalt binder, not the asphalt itself, but the binder is 25 million tons per year. Global market's 140 million tons per year. And it takes 2 tons of coal to make 1 ton of binder. So that's a lot of coal that we could sell. So SCR, with School of Energy Resources, and WRI, which is the Western Research Institute, which is who we are collaborating with, we believe that we can move this to commercialization. And basically the Wyoming legislature has just given us $17 million to help us build our field demonstration plant in Gillette to build a road. So we're going to actually have a road, hopefully in 2026. I mean, that's a fingers crossed thing, but in 2026, we're actually going to build a road out of our coal-derived asphalt binder. So there you go. One of the other things about asphalt, this is also a big surprise to us. So cradle to gate, if you take a look, Powder River Basin coal has 3 times less the upstream CO2 emissions than its petroleum counterpart. So that's another really big hole in asphalt. And we've had a lot of people, well, not a lot, but we have some people, the DOTs around the country have started looking at this. They weren't really paying attention a year or 2 ago, but now they're starting to pay attention because everyone's looking at greener supplies, right? And even CDOT, even Colorado is looking at it, which is amazing. So because they're mandated to look at green materials. So it's kind of painful for them to think, oh, green materials, oh, coal, oh, green materials, oh, coal. So it's kind of, they're trying to figure that out. So there you go. So anyway, so here's some of the other products we're making in the carbon engineering initiative. We've got the char bricks I talked about. We have stone veneer. We have block pavers. We have a carbon structural unit right here. If I can not move the slide right there. Okay, that is we're making that also with the coal char, and that is what you would use to actually frame a house. So that is stronger than wood and it doesn't burn. Isn't that amazing? So then we have our soil amendment. We also have graphene oxide in concrete. If you put a little bit of graphene oxide in concrete, it increases the concrete strength by 27%. So that's another positive here for that. I wanted to also talk about our field demonstration plant. We have started work on building our field demonstration plant in Gillette. Over here, this on the left, that picture was taken in February, and then in March they actually laid down these pillars here, right here, okay, for a rotary kiln that we're going to be using in the process. And there's our rotary kiln that was just set yesterday. So we are really excited about this. So anyway, so that's what I have. If you have any questions, I am here for the break and anything, so our lunch or whatever, and let me know. Thank you.
Thank you, Trina. Next, we have Rob Sincata. He is from the University of Wyoming College of Engineering, and he is going to be discussing coal-derived products and machine learning.
Thank you for the introduction. So I'm Rob Sincata. This work that we're presenting on is part of my PhD dissertation, but I've spent 5 years thinking about what's in here. So I hope you all bear with me. So to begin with, this is our process. I think Trina has covered a good bit of what leads into this process, those first few items up here with the solvent extraction. And our goal was to take some of the fractions of that aren't being used in the other processes and see if we can make carbon fibers for batteries and other energy storage devices out of them. And to do that, we're utilizing an electrospinning process here, where we're making carbon nanofibers out of these out of these solutions. So when we get the extract materials, we've got to think about how can we manipulate these so that it can go through the electrospinning process and actually make usable fibers. So we've looked at adding polymer binders, so that's commercial polymers, polyacrylonitrile, things like that. But we've also looked at, can we polymerize these fractions and make our own polymer binders out of them? After that, we go through two different heat treatments. There's an oxidation, which is lower temperature in the presence of oxygen, and then a carbonization, which is higher temperature with atmosphere like nitrogen. And the end result is a fiber mat like this, which has properties and chemistry based on our choices to manipulate and the precursor that we put into it. So we can tune our properties, the surface chemistry, what is the pore structure, what is the morphology of the, based on our decisions process. And the end result is we're able to make a device. We can electrodes together with a separator and current carriers to all symmetric, that we can charge off of solar panels and run LED lights on. The possibility in the future of building larger devices. So here is our polymerization process. What we have is the solvent extract we're choosing, which is rich in phenol groups, and we can use those phenol groups then to react with toluene diisocyanate to make urethane linkers, and this ends up with a polyurethane resin that we can then add to a solvent with other coal fragments to make our spin. Here's SCI images of the carbon fibers that we're making, carbon fibers. All of these are on the order of hundreds of nanometers thick. They're a lot thinner than what you would get from a mechanical spinning process. That's the big advantage of the electrospinning, is that we're making nanostructured materials. And we see all the typical trends that you would normally expect. When we increase the carbonization temperature, the fibers get thinner, so they become smaller diameters. And when we add coal fragments in addition to the polyurethane, get thicker with more coal fragments. And we've done a study on the carbonization, like the polyacrylonitrile, the commercial binder. We don't know much about what happened. Here is that there are a couple peaks that aren't common to the carbonization of other polymers, which we called routine 1 and routine 2. And these are associated specifically with the carbonization of polyurethanes. So we know we have polyurethane in here, and we know that it's breaking down. We have FTIR data that confirms we're products associated with breakdown of polyurethane. And here we see the Raman spectra. So this is a common experimental technique that people will use to characterize conductive carbon materials. There's 3 peaks, which are common across carbon materials, D, G, and over here is an overtone of the D peak. We don't need to go too much into detail about what these mean. If we had a pure graphene without defects, there would be no D peak and there would be no overtone to the D peak. We would only have the G peak. So what we've got is something that is a lattice of carbon material with lots of defects and lots of functional groups that are donating electrons and holes to the structure. And here we wanted to see how do the functional groups affect the conductivity of these carbon fiber mats, because that conductivity is also related to the performance. So we're comparing a 4-point probe conductivity measurement to XPS peak areas of organic nitrogen groups. And we see the trends are conserved whether you're looking at the increasing loadings of coal fragments results in decreasing conductivity and a decreasing ratio between the Q and the P nitrogens. And same thing with when we have an increase in the carbonization temperature, it goes up. And so when we go through this after years of experimenting and trial and error, we can come up with how do we tune our process and decide which. Here we're comparing 2 different types of coal fragments inside that polyurethane binder, the residues and the deposits. Those are just 2 different fractions that the residues are giving us the best performance. We're looking at around 600 farads per gram. And this is very high for in another slide. What we also see in cycle stability, in terms of cycle stability, a region of activation during the first 1,000 cycles. And after that, these materials are very stable. We get the same capacitance coming out of them. over the next 10,000 cycles. So here we're comparing our material to various commercial activated carbons. You can see Maxwell is a company that makes supercapacitors that has recently been bought out by Tesla. We also have activated carbons from Norit and other commercial activated carbon manufacturers. And our material outperforms these materials. We get broader charge discharge profiles that results in a much higher capacitance. And in a symmetrical 2-electrode cell, we're getting a better trade-off between energy and power density. So for a battery that's discharging at the same speed, we can discharge. And machine learning, this work is largely in a preliminary stage. So I'm going to data that we've worked on so far, but we've applied 7 different machine learning techniques to try to predict the capacitance that we'll get out of carbon emitters and the composition of the precursor solution. The hope is to eventually iterate this process so we can use this to help us optimize the process design. So in the future, when we're given a new precursor, we can cut down the time that it takes to develop from 5 years to a much shorter amount of time. So one of the things that we'd hoped the machine learning algorithm would be able to capture is correlations and relationships between process parameters. So what we have here is a correlation matrix. If the value is 0, then those 2 variables are not correlated in a linear way. If the value gets close, and so what we see is that some of these parameters are strongly correlated, and some of these parameters are not so strongly correlated. And we used a lasso regression as a dimensionality reduction to, and that is what we found. Right now, we've got models from these machine learning techniques that can predict to a certain degree of accuracy with 0.5. We're working on our data set, refining that to see if we can get better. What to do is start guessing process experimentally and iterating that so that we can use these to optimize the process. So we'd like to thank our funding sources, and I thank you for. So we'll move. I'll bring the floor back to.
Thank you, Rob. Okay, now we are going to move on to talk about business, industry, infrastructure, and economics. We have 2 presenters for this next slot, Daniel Cooley and Angela. And they are from the University of Wyoming Center for Business and Development.
Hello, everybody. My name is Angela. I'm a research assistant. And today I'm going to give you a quick summary of the business, CORSAIM business survey that we've carried out. So we've interviewed several business perspectives from the CORSAIM supply chain participation. And the respondents identified like one of the main benefits that came to light were additional revenue and trade in the associated with the CORSAIM supply chain participation. On the other hand, uncertainty relating to CORSAIM regulations and market demand, technology, and production process was cited as the main risks involved with the CORSAIM participation for those businesses. And the graph on the right, or on the left, is essentially a more detailed breakdown of various barriers to entry identified during the interviews. And in addition to regulations and stuff, also and other factors preventing free entry into the CORSAIM supply chain for those businesses. Notably, 50% of companies that we talked to said that they don't have access to the information that is required for them to actually enter the CORSAIM supply chain. And amid the most notable areas of lacking information is market demand, as in like businesses didn't know like what their customer base is going to be, or like where to ship their supplies. And another big area of lacking information is technology. So essentially, not a lot of information is there in terms of how to turn that research into a valuable product. Graph on the right talks about workforce development, and this area also has some issues. Mainly, the main problem is a shortage of qualified labor supply, and a lot of businesses cited that they have a lack of experienced welders, mechanics, electricians, and engineers. But despite that, like almost all companies put a lot of effort into training their own workforce. or into hiring trained workforce, or providing internships. So anything that could help them to have that qualified people to work on the course games. Sorry. And currently what we're working on is a story map that would aggregate all of the information that we currently have on CoreCM in terms of energy sources, coal mines, transportation infrastructure that the region has that can be used to propel CoreCM supply chain development in the region. And our next steps in developing this story map would be to add information about water resource and uses, permits, community engagement, and also CoreCM use cases. For example, what elements go into production of magnets, and like how much of those elements we need, and like what impact would that have for companies that are producing that. I wanted to say also that we're still looking for people to interview. So if you would like to share your perspective, please reach out to me. I'm going to be here, or you can maybe send an email to me or Erin. Really appreciate that. Thank you.
Hey, I'm Daniel Cooley. I'm the energy economist for the Center for Business and Economic Analysis at the University of Wyoming. So not only do I do the CoreCM for PRB, but I also do CoreCM for the Green River Basin and the carbon stations. So what I'm going to talk to you about is kind of determining the priorities of some of the resources that we do have in the PRB, because while a lot of them are potentially economically viable, looking at which ones would have the most value is going to be a big step in the process to figuring out which of these get our money first. So we've already talked a little bit about the critical minerals from waste streams and non-thermal coal uses. I'll talk about the non-thermal coal uses first. It's a lot of construction material, and it's a pretty high volume alternative for coal at the moment, moving away from coal. And keeping those coal mines open is going to require alternative uses like this in order to actually have a valuable product in the future. Now, coal for energy is not going away anytime soon, but it is getting there, kind of crawling to that point within the next few decades. And then it also, these materials also have substitutability with traditional materials. As Trina said already, they have different physical attributes. So the things that we would look at economically are the differences in price between these and more traditionally produced process, but also for constructing these types of plants that can actually do this. And then also the scalability. It's great if we have something that's a cheaper alternative, but if it's not scalable, it's not going to be able to keep up with production materials. And then kind of the lot of the talks today, critical minerals from waste stream, so mine tailings, byproducts, things like that. Some of these do have some economic differences between how we view them, view mining for these kinds of critical minerals from traditional sources. A big one, not as much of a concentration even in these waste streams as there is pure mining directly for these critical minerals in the ground, like they do at Bear Lodge. However, it is a lot better than mining directly from the ground in the areas where those materials are from. So it is to some degree enriched compared to the actual coal benefit. However, it might not actually be cost efficient to mine these resources, even though they are better than just taking the coal directly out of the ground for the sole purpose of critical mineral extraction. They might not be cost competitive with traditionally mined resources, which is a problem because most of those traditionally mined resources are from countries that don't necessarily share our political alignments, like Russia and China. And there's also a lot of global market pressure in when and how we can actually mine these resources. So the example that I have up here is for vanadium. When the price, so vanadium is a co-product or a byproduct really of uranium mining. And the only production in the US comes from energy fuels, and it's very intermittent. So as the vanadium price goes up, we can see in 2019, we started having some active US production of vanadium from those as a byproduct of the uranium mines in the Colorado Plateau. And then as soon as the price went down in 2020, that production tapered off very quickly. So these global market pressures, particularly with just how much quantity these nations that have greater labor force and greater traditionally mined resources than the US does, really has a big impact on the price. So the more another country, whether it's China, Russia, Brazil, or wherever, is able to mine and extract these resources and import them into the US, the lower that price is going to be, and the less incentive there is for a company like Energy Fuels to use that vanadium, even though it is a byproduct of the uranium mining process. And then to kind of help visualize this, I've made a heat map for aluminum sources consumed in the US. So it's mostly importing. We do actually produce a lot of aluminum in the US. It's mostly from recycled materials. But we still have a 54% reliance on foreign imports. And so what I want you to look at here is how particularly Russia and China move through time. And you also see some differences in Brazil, Venezuela, and around 2016, you'll see India come online as a pretty big exporter of aluminum. So you pretty quickly start seeing that Russia is getting lighter, implying that we import less from them. China is, however, getting darker. You see that Mexico is also getting darker. There's not a difference in Canada and the US because we already manufacture a lot of aluminum. The red areas are 500,000 metric tons or more produced and used in the US per year. Whereas anything that's lower than that, those gray areas are zero, and then most of those yellow areas are in the tens of thousands of metric tons. And then you can see India has come online, and then 2020, global pandemic kind of killed some of the exporting from a lot of countries. But I think that paints a picture of where a lot of the aluminum at least is coming from, and I'm going to do a similar heat map for all of the other critical minerals as well. I think it'll be really interesting for a lot of the rare earths. You'll see a lot of that's coming from China, and that hasn't changed in the last several decades. And then once we do kind of figure out which of these is the highest priority and which of these is worth moving forward with, those technologies and the facilities required to actually manufacture them will require an economic impact analysis. This isn't something that we can actually do yet, simply because a lot of these technologies are still in development. The costs associated with them aren't necessarily known for bringing them to commercialization. Once those costs are known and we can start looking at that, we'll look at how they affect the local economy for whatever state they're in, and also looking at how they'll affect the economy of the US in regards to how many jobs they create, what it is that they're able to produce in labor income and value added and things like that, and then how their employees spend their money in the economy. Are they spending their money on clothing or whatever other products they buy, and look at kind of the total impact, both direct, indirect, and indirect of these companies and industries coming online in the near future. That's all I have. Like I said, I do quite a bit for the SCR. So if you have questions for me about economics, it's likely that I have some information on it, and I really like talking about this stuff. So if you want to talk to me, just let me know.
We do have time for a question. Does anyone have a question for Daniel or Angela?
So Angela, there's a nice story map you had with different businesses across the basin. Can you just kind of tell us what some of those categories are? They're kind of hard to see from our viewpoint.
So it's like the map actually has more businesses than just mines and power plants. So these snippets, they only show I guess the most critical ones, but they also have supporting industries and transportation infrastructure, and pipelines and railroads and stuff like that. There's also, we're going to add stuff about workforce. Yeah, I guess it's not a very huge map at the moment. It just covers, I guess, the basic stuff that you need to know if you were interested in consortium, supply chain, either participation or just general interest. But yeah, we're
a lot of rare earth elements are commodities that are traded globally, so you can always find quantities and globally traded spot prices. Whether those are accurate is another question. But there are some places that do have that data. Shanghai Metal Markets is a big one. Other companies like Roskill, or I'm sure there's others, are also collecting that data mostly on a daily basis. Sometimes it's a monthly or yearly basis. And then the USGS also has annual pricing data for imports in the US specifically, which might not line up with global prices, but they'll be pretty close. There's not a lot of variation between how we price things in the US and how the rest of the world prices things, which is also part of why we continue to import from other countries. Yeah. So the data exists, whether you believe the data is, you know, kind of up to you. It is also kind of want you to have some kind of subscription, and it's often in the tens of thousands of dollars to get access. Yeah.
Okay, thank you, Angela and Daniel. Next, we have Selena Gerace and Madeline Lewis from the UW School of Energy Resources, and they'll be discussing communities, social and environmental justice.
All right, thank you. Thank you. All right, good morning. My name is Selena Gerace, and I'm a research professional at the School of Energy Resources. I focus on a lot of our social science side of our energy projects and how they impact communities. And I've been working on the environmental justice.
My name is Maddie Lewis. I am a research professional at SCR. I'm an attorney by training. I'm licensed in Wyoming, weirdly Montana. And I say weirdly because I'm never used to be back for once, but yeah, I focus on a lot of environmental justice issues surrounding energy projects, community engagement, and I'm really focused on policy issues and law and regulation as well.
Great. Working closely on this environmental justice subtask, the PRB CORSIEM project, to develop like a summary of environmental justice related to developing these critical mineral in. And so that focuses both on what these industries can help to remediate like past environmental justice concerns, as well as what might be environmental used a lot, and it's never that clear what we mean environmental justice. So this is a subset of social justice and the social justice movement, which has to do with this advantages and disadvantages across different populations of people. So regarding race, socioeconomic status, other demographic qualifications. Environmental justice, again, is that subsection that has to do with that the distribution of those advantages and disadvantages of environmental factors. So it gets talked a lot about in terms of energy and all natural resource development. So environmental justice, there are several different frameworks through which we can think about it. And that one that I was just describing describes this distributive justice framework pretty clearly. This fair and equitable distribution of environmental benefits and burdens. We can also think of it as there's procedural justice. So that really has to do with process and who's involved in the process. How are people empowered and able to be involved in decision making? How are they engaged throughout the process? There's also restorative justice, and restorative justice has to do with how do we make up for historical injustices? How can we start to account for some of those injustices that have happened in the past? And these are just three frameworks. There are others, but these are three of the most common ones. So I'll also share with you this definition of environmental justice that the EPA developed, and it's the one that gets used by the federal government a lot, and it's the one that the Department of Energy is using. The fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. So it really hinges on these two concepts: fair treatment being one of them, and meaningful involvement, right? So that fair treatment, again, has to do with that distribution of advantages and disadvantages. And that meaningful involvement has to do with that engagement part, and that being included in decision making, having a say in the process itself. So when we start to think about this environmental justice for critical mineral industries, it's important to recognize the complex supply chain of critical mineral industries, which has been pointed out several times today, that this is a long and complex supply chain. And often we think of environmental justice kind of narrowly, that we can easily focus on it just at the site that sometimes is most visible. For example, at the site of production or combustion of something. But actually, there are environmental justice considerations throughout the whole supply chain. So that is one thing that's important to keep in mind as we're developing these industries. How can we incorporate environmental justice at all stages of the supply chain? Okay, Maddie, I'll pass it over to you.
All right. So I think when we're talking about environmental justice and what the industry looks like and what the future is, it's obviously important to contextualize, the issue in the broader supply chain and the state of the industry. So it's already been said several times today, mining and processing activities are concentrated in just a few countries. So here for cobalt, for instance, nearly 70% of extraction occurs in the DRC, 65% of processing occurs in China. What isn't said there is that even the mining activities that are occurring in the DRC are by and large controlled by Chinese companies that, at least have ownership positions in those mines. And lithium is another good example. A large portion of extraction occurs in Australia, also in Chile. Again, processing is concentrated in China. And, same with graphite and rare earths. So the US is really struggling to develop its own domestic supply chain and trying to figure out its foothold in the global market. So there are, could be a number of reasons for why the United States has not kept up, but one of the reasons that we really need to think about a domestic supply chain, other than national security concerns or just ensuring that we have a reliable supply, is the fact that in those countries where mining and processing activities are so concentrated, there's also high levels of environmental social governance risk. So that includes things like child labor. Unfortunately, that's a big issue in the Democratic Republic of the Congo, where there are a lot of so-called artisanal mines where children are just kind of in there digging with their hands, and communities are seeing virtually no benefits from that type of mining. There are also, other types of labor and human rights abuses. And I think overall another concern is expropriation. So you see in some countries that have maybe unstable governments or governance risks, you can see governments kind of taking control of mining assets. I think that recently happened in Mexico with the case of lithium. In the United States, though, we do face some challenges. So the permitting process for this type of mining is really lengthy and unclear. For most mines, it can take I think they're averaging around a decade for permitting. And there's typically a lot of litigation that goes into it as well. So our current mining law is also really archaic and anachronistic. It's the General Mining Law of 1872. And that's, there have been reform efforts over the years for many years. And here we are still with a 150-year-old law that essentially was designed to encourage settlement of the West. It said, if you go out and locate a claim on a valuable mineral, it's yours. Sometimes you could get the title with it. Obviously, that kind of thing doesn't fly today. You can't walk on public land and find something and, get title out of it. But I think there's a lot of issues when we're thinking about how this type of mining fits into the laws that we do have. And yeah, again, environmental review issues are pretty prevalent because so many deposits are located near public lands. That also means that they're sometimes sited near areas of cultural or environmental importance. There's a litany of examples for that, including, the Thacker Pass mine in Nevada had a golden eagle issue. The Pebble mine in Alaska was right next to a very culturally and environmentally important salmon run. And another example is the Resolution copper mine in Arizona is located on some sacred land to the Apache. And these challenges have been around for a while. There's some barriers there. So just from a policy perspective, there's been a lot done at the federal level to start encouraging development of a domestic supply chain. And I'll talk about those environmental justice components that feed into that as well. Starting in, I'd say in our current era, about 2017, the Trump administration directed the creation of a pretty lengthy and comprehensive report designed to just identify our weak spots as a country and where there needs to be build out of a supply chain. Then in 2021, the Biden administration ordered a similar review of vulnerabilities in the U.S. critical mineral supply chain. Is the Biden administration's emphasis on environmental justice. So virtually every federal agency now has an environmental or social justice task force within it. Pretty much every, to the extent possible, we'll just let recover Kyle. Every piece of funding from the federal government for energy projects in particular is going to come now with an environmental justice requirement in some type of community. So that includes those requirements attach a lot of funding that was made available under the Infrastructure Investment and Jobs Act, otherwise known as the Bipartisan 21, and as well as the Inflation Reduction 22. But there's a lot of new funding coming out under just giant endless buckets of funding in some ways. I think just yes, 4 new advanced processing awards announced minerals. But that leads to questions of, what communities are going to site these, where is there going to be social?
Really to take account of the community impact and environmental justice. We see that there's a big opportunity in developing these industries for coal communities in Wyoming and we think it's really important to take a very place-based approach to developing these industries where we take account of what the unique social, environmental, economic factors are that are impacting these communities. A lot of these communities are ones that have been built up around coal industries, around coal mining and coal-based power plants. And are very much embedded within those communities, their jobs and their livelihoods and the way these towns operate. And so there's an opportunity for this to be economic development of these same resources that will provide job creation and job creation to local people, not just bringing in people from other communities, an opportunity for local training and education and utilizing that skill set and that workforce that's already there. It's an already trained workforce. There's an opportunity to have really positive environmental impacts. There's opportunities, as we've been talking about here today, to utilize waste streams. So there's actually creating this circular economy of developing critical minerals that will then go on to contribute to clean energy industries. There are a lot of other economic benefits in terms of economic development and diversification, as well as a real opportunity to engage with communities and develop these industries in alignment with community values, to take account of how do communities want these industries to be developed? How will they support the values of that community, and how can we do it and develop social license to operate? So as we've been working through the environmental justice subtask, we've been working really closely to engage with the communities, working with community colleges. We've been working with Gillette College and other community organizations, engaging with policymakers, and working on developing workforce development and education opportunities. We've been working with a guidebook for developing environmentally just industries. So we plan to continue this work as we move through future phases of this project, and would love to talk to you about your thoughts about how to go about building this ethical supply chain.
All right. Thank you, Selena and Maddie. And we'll have a panel this afternoon on communities and workforce development. So we look forward to talking more about this topic then. All right, next we have Christine Reed and Kyle Summerfield discussing our outreach and education efforts.
Great, thank you. We'll let Kyle get this set up. I'm not going to be too long on time because Kyle has much cooler things to show you. So I want to make sure that most of the time goes to him. But I do have a couple of things to do while he brings them up. All right. So as I mentioned, I'm Christine Reed. You've all communication and education on this project. First and foremost, I just want to thank Gillette, also our partner on this task. They've been really helpful, just as you keep hearing over and over again, piece of making sure that we can of like workforce training and development. But overall, task 7 is mostly assessing what we have on workforce training, community and outreach and education. So primary objectives, providing information on the project to the target community. So we spent much of the first year sort of questions, who needs to be in the room, who do we need to be talking to, and what questions need to be asked. And so this is kind of fun to see us a year and a half of stuff to share as you've gone through everybody else's presentation. So our job now going full of that really great information and to continue to share it with all these stakeholder groups and what kind of training programs are there, workforce entities. And I will say, admittingly, most of our efforts have been pretty Wyoming centric to this point. So we are really excited to be up here in Montana and moving forward through subsequent phases. We're really efforts and grow that out into the regions. We've also identified gaps in communicating the training. So we know some of the communities that are a little more difficult to, we certainly experienced challenges with, I'll get into that a little bit later, but we want to make sure that they're an important voice in the conversation moving forward. We have, for example, and like really downstream side of the supply chain, start making more connections there. And then recommendations moving forward. So there we go. Okay, so just to show some of the things that we've done, obviously, annual forum, we had our first one in Gillette in 2022, which was really, really great to see what sort of interest has come, and we're just overwhelmed by the projects nationwide. It's gonna be really important moving forward, especially as they become more regional. So those are some of the things that we've done to reach out with some of our neighboring states and projects. And then, of course, like the basic thing is to try to get this information out to the people. So everyone in this room, you know, has some sort of like a technical background. And so a really primary objective for us is to kind of translate some of this very high scientific stuff into an understandable and digestible format for the lay person. And so we can actually get into the community. So we have a really great graphic designer. Sabrina's out there, she's fantastic. So we've been trying to do some just like high level overviews of what this is and how it works. And this is just some examples of that. We've also developed a webinar series throughout the course of this project, and all of those are online as a really great resource on various topics. And so those are accessible to the public on that website. And then of course the Makerspace badge, which I think Kyle will talk about a little bit more to help workforce training. And then talking about our tribal engagement, this is really, really important. This has probably been the biggest learning curve for us. And I think the best thing that we can do has been to create opportunities to listen. We really don't want to be going and engaging with our tribes and telling them what we need from them. And so we've been really diligent in trying to just make connections that are going to be lasting over through the course of the years. And we've identified some like long-term goals and things that we can do in the interim. So some of the things that we've identified that can be helped in the interim is to create more of an educational channel between tribes and like the university as a whole. So we've kind of worked with our academic program to try to cross-list courses, get students to visit campus. And so there's a little higher energy IQ. And then we've also invited them to teach us. So we held an event on tribal sovereignty that was open to all university leadership, so we can do a better job of understanding how things work for them and how we can better engage with them. And we've also tried to create resources as well. So we are working on sort of a permitting guide for any sort of like critical minerals on tribal land. One of our law students worked on that. So that is currently under review with tribal members, and we're hoping to get that out before the end of this project. So talk more about how we can get some of this information out in a really cool, accessible way.
Thank you, Christine. Just a second here. Okay, we should see my desktop now. Great. Okay, I am Kyle Summerfield. I'm the program manager in that position for a little over 2 years, but I've been our lead developer for close to 10. So I have a lot of experience developing on a bunch. I'm going to show this short sizzle reel, and I'll talk a little bit over top of it. So this is kind of the main room. That this cube is the cave. This is subsurface data for the state of Wyoming. That's me with more hair and less beard. This is largely chronological, and you can track that chronology through that hair displacement. So you can see this shift in focus though from showing large scale VR bespoke installations to consumer headsets, and then in a second, mobile devices. This is our 360 camera that we use for, capturing 360 photos. The cool thing about that camera is that it has separated left and right eye images. So when you're in a headset, you get that sense of depth and scale. Here we're looking at some desktop deployments and mobile deployments. This is to visualize the depth of these carbon injection wells. This is our structured light scanner for getting sub-millimeter accurate scans of objects. There's the hand drill that I was just scanning. That's some art. That is my newest employee. Okay, so I'm about to do what I would consider a rather brave thing, which I'm using synonymously in this context, which with ill-advised or potentially a bad idea. But I'm going to do a live demo of the app that we're working on for outreach and education stuff. So there are really two sides of this app and therefore two target audiences. There's the side for the researchers and people that want to get information out. That's what we're looking at on the left. And then there's the app itself, which is on the right. I'm running this live in an emulator here. Okay, so there are a bunch of new features since last I talked about this. So let me just kind of start running through them. So the app is organized into tabs and articles. I'm not going to be able to cover everything right now, but you can see over here that I have 4 tabs defined, and over here there are only 3 tabs showing. So if I wanted to introduce the article interface. So there are a bunch of articles pre-populated here. I'm going to make one of those so I can walk through some of the features. So we'll give this a title. We'll give it a subtitle. These are optional. The subtitle anyway. We can give it a publication date. We can set it to the current time, or if we want to schedule a publication, we can set that in the future. It'll automatically populate in the app at that date. We can also define tags. So these are really useful tools in the context of this little interface. I have a few defined, and when I start typing, it's going to filter for what's available already. I have a testing tab that I'm going to use for this demo. So I'm going to give this article the testing tag. For cover images, we can upload all of our own images if we want to, but we also have a guaranteed reusable asset library here that you can search by topic or color. So if I wanted to say, I don't know, I want a green image, it'll give me a variety of those. These are all guaranteed copyright free. Let's say I want an energy related image. Cool, so let's go with this one. Now, for ADA compliance purposes, it's necessary that you add alternative text to describe the image for screen readers. So these were power lines. These won't actually appear in the app if you want, but somebody was using a screen reader, it would read that image out using that text. So if I wanted a caption, I could put it, caption text is optional. And then in the content page, I mean, this is really the meat of the article we're posting. So obviously we support text, we support common markup languages, all the normal tagging stuff that you might do, but we can also embed several different things. So I'll show you an example of an embedded YouTube video. Another thing that we support is we support Esri web maps of all different flavors and scales. And we also support Sketchfab embeds. So Sketchfab is a 3D model repository site. We're the 3D Viz Center, so we need 3D models to be supported in this app. So I've created, I'll put something in here. Oh. Okay. And I'll go ahead and populate these tags. So now, if we look at the tabs here, and I want to, let's say I want to add my testing tab, and I don't want to manually populate all of the articles I want to appear on that tab. So for example, if I went to the speaker series tab, we can see that a bunch of, or some number of articles have been added to that tab. If I wanted to add an article here, I could do it individually. I could say, here's all the list of existing articles, let's add this one. When I publish that, and then go to the speaker series tab over here and refresh. Oh, if we're live. We now have the new article listed here. And this is I'll talk about this in a minute. But all we have to do is just hit publish there, and suddenly all of our tabs are populated and updated. Another cool thing is, let's say I made some change to this article, or I published it with a typo, something like that. I have version control. So every single article, tab, and image is versioned. So if there's some mistake that happens, it was previously correct, you can always roll back. Okay, now I want to show this test tab that I made previously, but I want to automatically pull in all the data that is tagged testing. So you can see it's actually already done that because I added the testing tag earlier last night, which ruins the flow of this whole thing, but whatever. Here we have the new article that I just created. And if I publish this tab and come back to the emulator, you can see that our test tab has appeared here. When you make one of these tabs, you get a bunch of options going through. So these images on the bottom are SVG files that are contained in a similar library to the image library. What am I doing on time? Okay. Those are all guaranteed reusable. They're SVG scalable assets. So then their coloration will be based on the gradient that you choose for the tab. So I did forget to show you that. If I go to our test tab and edit, we have a predefined gradient list. You can also make your own, but you can pick from any of these lovely gradients, and the bottom color of that gradient will be the color of the icon shown here. The latest feature, oh yeah, let me show you two things. So in my test tab here, I have a test of an Esri embed. So this will open within the context of the app. And these will have all the features of whatever Esri product you've been slaving away on right in the app. It doesn't need to pop out to a separate environment. Same with YouTube. So I think I have one in Mark's page here. Yep, so this can embed right in the app, or if you want it to pop out, that's also already built in. The latest thing that we have working now is our search field. So if I had a huge list of articles and I didn't want to scroll through them, I can search up at the top here and it will filter everything out. We can also pin articles. So normally it will post them chronologically, but if there are some that we think are going to consistently be more important than the others or should be the first thing that somebody encounters on that tab, those can be pinned. We are pretty close to done with this app and ready to get it out the door, but it is at this point that it's relatively easy to add support for embedding of other different file types or iframes or whatever. So I'm looking for feedback on that before we get it all the way out. Again, there are two audiences here. There's the content creators and researchers, That's the interface on the left. And then there's the public or stakeholders, which is the interface on the right. All right, that's about what I got.
Thank you, Kyle and Christine. So we have discussed a number of those areas of focus for the Powder River Basin thus far today, and we're going to take a short trip away from the Powder River Basin for the next talk before we wrap up the morning talks. As I mentioned in the introduction, there are 13 core CM projects funded across the country, and the University of Wyoming School of Energy Resources is also leading a project in the Greater Green River Basin and Wind River Basin. So Bob Gregory is here from School of Energy Resources to give an overview of that project as well. There's lots of overlaps between the Powder River Basin project and this project, and lots of opportunities to work together there. So thank you, Bob.
Okay, yeah, thanks very much. So what Kyle and Christine presented just a bit ago is what I would consider a tough act to follow. But say it really rocks. Speaking of rocks, let's get back to actual rocks. This is about as good as the jokes get. I'm the task 2 lead for the Greater Green River Basin, Wind River Basin core CM project. As you'll see in an upcoming slide, it involves much more than just those 2 basins. And so there's the Powder River Basin, which covers northeast Wyoming and southeast Montana. And for the Green River Basin, Greater Green River Basin project, it's pretty much everything else, except for maybe Yellowstone, Jackson Hole. They get a little upset when you get rock samples in Yellowstone. So we're not going there, but we're going as many other places as possible. You're familiar with this. Basically just means I don't represent, what I say isn't necessarily what the DOE says or the federal government. That's kind of good because it's kind of fair, because when they speak, it's not necessarily what I think either. So it's all good. But we're very grateful because they provide great opportunities for some really interesting research. And it's not only that, but it's great to work with such a nice team of people associated, not only with SCR, but all our stakeholders and all our contacts at the mines. They've just been terrific to work with. So like Aaron alluded to, see if I can do this without changing slides. Region 9 there, as you can see, as defined by the DOE, that top green polygon is the Bighorn Basin. Below that is and then where the 9 is, that's the Greater Green River Basin, because it encompasses several sub-basins. And that, while that gives us a lot of cool stuff, presents challenges because no 2 of those sub-basins are exactly alike. And in fact, within the Green River Basin itself, there are coals of different ages. We have Cretaceous out in northwest Colorado, and then we have Paleocene aged coal around Rock Springs, so Fort Union Formation, same basin. You probably read through all this, and Tyler, by the way, did an excellent job of explaining the core CM process. I won't get into that, which is good because I hadn't planned on that initial gap, basically identified by the government, wherein we are lacking in our ability to produce rare earth elements and critical minerals ourselves, and we're very reliant on imports. That's a big gap. So that's what leads to all of this. And so we study the rocks, we get data, we try to formulate models. That will inevitably lead to gaps in what we know, and it will point us in the right direction, what core CM is trying to accomplish. I guess I touched on this pretty well earlier, but Greater Green River Basin, also include a little bit of the fold and thrust belt. That's where the Kemmerer mine is. Black Butte, Bridger mine, historic mines in Wind River Basin, Hanna Basin. There was a historic mine there, it's no longer operating. This is where Walden is. And then we've got 3 nice mines still producing in northwest Colorado. So who am I working with? This project is led by Davin Bagdonis, and Dr. Phillips here directs both of these core CM projects. And Nate Rogers of the Colorado Geological Survey, they've been instrumental in helping us get not only data, but samples. Alex, he's an expert in coal geology, primarily in Northwest Colorado, but he also is very knowledgeable. He's helping us with our modeling. Lily Jackson also has been helping us with our modeling, and Grant is our geochemist. Unfortunately, he's leaving soon, but some of our sample analyses. Okay, so this is the task that I lead. It's at the top there, but what it boils down to is what very well. We assess coal stat. I just mean pretty much the coal bed and the rocks, and that includes overburden, underburden, interburden, typically interburden. Well, oftentimes in what I find are the most interesting instances is volcanic ash. Are instances where I've seen some interesting associations with volcanic and coal sediments. And there are other instances where there's no kind of, it's there, but it's the source of the volcanic ash. And so in addition to the coal sediments, we look at the non-coal sediments and coal-related products like ash, refuse in this project, but we look at it when we can. And these other basin materials, very interesting as well. Heavy sands, I'll talk a little bit more about that later. Clay, seen some associations with rare earth being affixed to clay minerals. The Trono waste streams. Sure of a little bit of sampling we did on a Trono. And phosphate waste streams. We have some on that. We're not allowed to discuss the actual data. It doesn't look bad. And then include Precambrian rocks, pegmatites, altered rocks, fault zones, that sort of thing. Doesn't always hold interesting levels of rare earth elements, but oftentimes it does. And so all this, like Tyler alluded to, we work this into the best kind of geologic model we can. That will inevitably disclose gaps to us where we need to learn more. Sometimes we can fill those gaps, oftentimes we can't, but we do the best we can. So once we have those gaps, process starts over again, and we collect more data from the areas where we're needing more material. Okay, so this slide is from the Colorado mine down in Northwest Colorado. If you look right along here, that's an ash bed also. And so we got a couple of samples of that. That's kind of a fisheye view of what's called the column pit at the Colorado mine. These folks are very good to work with. They let us go out and get some samples also provided. I think I mentioned most of them. Kemmerer, Black Butte and Bridger mines just outside of Rock Spring. That's the Colorado, Trapper, and Foydle Creek mines. We recently got some from Foydle Creek and got the data back about them. So pretty encouraging. Hannah Coalfield, retired mine, but I was able to get some samples from the core down in Lakewood on some core that was drilled there, 80s, I believe. We have our eyes on some coal bed methane, mostly Lance age, I believe. They're Upper Cretaceous. We don't, but that's, again, that's one of our gaps. And the basin has some coal bed methane areas as well, and from there, from the Core Research Center. We kind of touched on this. Where do we get them? From mines, outcrops whenever possible. We do have some of those. Our friend Trey got some really good samples for us there. Coal Qual database. Tyler and Ryan, I think, talked a little bit about that. And as much other legacy data as we can from state, federal surveys, papers, data mining, all those sources are very, very helpful. So some pictures of some of the mines that we've been to. Kemmerer mine in the upper left. That's the lowermost seam at the Kemmerer mine. It's the number 175. This is a large sandstone. It's covered with coal debris from the mining operations, but that's a stone called the Lazert sandstone. We've seen some interesting numbers of rare earth elements at the base of that coal bed there. Over here is a picture of the Black Butte mine on a very cold, windy winter December day, which I guess is kind of redundant on 2 or 3 levels, but very much so, trust me. And this is the Colorado mine. And interesting here, just kind of a interesting geologic phenomenon. These items here, that sandstone that was basically during settling, I presume, it was injected up into the coal seams and into fractures. So those are just little strings of sandstone that got shot up in there. And then the lower right corner, this is, see if I can stop from shaking so much. Ash bed and coal sediments. I sampled these and did a couple of GSA abstracts on this type of thing. Pretty interesting. Rather inconclusive because, as I mentioned, sometimes you see associations with rare earth elements, probably due from the volcanic ash. Other times it's absent. So it's just different volcanic eruptions. Some more pictures. These are some cores that were given to us by the Trapper Mine folks back in I believe this is 2022. Yeah, they were drilling at the Trapper Mine. That's Nate Rogers of the CGS, and they're actively collecting core there. This over here is an outcrop near the Kemmerer Mine, coal bed with a sandstone just above it. And again, a cold winter day, right off the outcrop. Okay, so far we've collected close to 600 samples, more in the works. These are just the coal-related samples. So what do we look at and with modeling in mind? So we're looking for the spatial relationships, geochemical relationships between the coals and the rare earth elements. And over there. This is from a paper that Magdonis et al. Together, or Montrose et al., excuse me. This is kind of our method. What we do is we look at the top few feet of the coal and the bottom few feet of the overburden. We try to get more samples there than in the middle, but we do sample throughout the coal seam. And in the middle, you can see that's what it's either an inner burden or a volcanic ash. I know it's hard to read, but we're interested in those areas too, because typically that's where we see increased levels of rare earth elements. And then these are some of the questions that we ask as we see these and try to gather this data so that we can maybe make our geologic models a little bit better at predicting where else we might find rare earth elements. This is a column from the basically it represents some of the coal beds in the Yampa coal field. As you can see, it looks pretty busy, pretty complex. Another challenge that we have is between the mines, they don't have all the same nomenclature. So one mine might call a seam A, the next one might call it X or G1, for example. So into our model, and that's what makes modeling basin very challenging, because there's a lot of different interpretations. Not that they're wrong, it's just that they're hard to bring into. So what we for now is mine scale modeling, where we can make a model of these sub basins and then, if possible, try to make some connection Greater Green River Basin. But what we're going to end up with several different models, but they'll have some. On the right is a it's a very good example of the increase in concentration of rare earth elements with the margins of the coal seams. These are two different coal seams from the same core, and you can see peaks at the margins and then not so much in the middle. That's a good example. Sometimes the data just doesn't line up that nicely. But what I've also seen is the more data you have, the better you can see these patterns. If, for example, some of our CRC cores, we were only able to get 9 or 10 samples. You just don't see a good pattern like this emerge if you only have a small number of samples like that, so. And this is my truck full of samples that I picked up at Trapper and headed back to Laramie. Okay, so some of the other sediments that we look at. Am I doing okay? I have 5 seconds, okay. Yeah, so this is a core through a trona bed, and it's west of Flaming Gorge. There's also, well, this is trona, and it doesn't hold up well to solution, so it gets dissolved pretty easily. There's also a lot of salt, halite with that core, and unfortunately, we didn't see much in the way of rare earth elements there, but it's on our radar, so we wanted to look at it. This is a landfill. It's volcanic, or not volcanic ash, coal ash, fly ash, and bottom ash. This one's volcanic ash. This is a tufaceous outcrop. Recently, we were lucky enough to get access to some samples that the Wyoming Geological Survey houses. Coincidentally, Dobbin and myself collected some of these samples about a decade ago. They let us get some more of those, and so those are on their way to the lab. They're tufaceous, that's what we were going for, and that volcanic ash rare earth element association is something that we wanted to learn more about. This is the Yampa bed. That's about a 3 or 4 foot thick volcanic ash associated with the mines in Colorado. A little bit about the mine modeling. We integrate the geology, we integrate our geochemical data. This is a figure of depth to coal in the eastern Green River Basin. And this all goes into mine modeling, and this is very, very preliminary version of where, or basically what we know, and error bars are very big, so take that with a grain of salt. A little bit more on the modeling. Matt Johnson did this. He combined gamma and density logs with depths, and the lights went out. Does it come back on? Okay. Anyway, I'm getting pretty close to the end. So current gaps, the coal bed methane, we want to get more there. Oops. There are other sediments that we want to look at. We recently got some encouraging data from the Denver Basin, but there's a lot of gaps in all throughout the study area. So, oh, okay. I guess I put some animation in here. These are the main areas where we have gaps. Same thing here. Whoops. Again, clays, phosphates, these are some of the other, there's a long list of things that if we had more time and more money, we would be looking at these. And maybe we'll get to do that in the future. Lastly, thanks to Ryan, I'm not the first person to show this, but this is the KT boundary in the Powder River Basin. I'm old school, so I say KT versus KPG. I just found it interesting because common to that boundary, there's thin coals above iridium-rich ash layer there, and so dinosaurs, no dinosaurs. Anyway, I know I'm a little bit over, so thanks very much.
Thank you, Bob. And I believe that last photo was from the Powder River Basin, so we're going to return to the Powder River Basin for just a few minutes here, and I know that lunch is the next thing on the agenda, so I just have a couple wrap-up slides here. Okay, so as we've heard from our update talks this morning, focused on these different topics, I'd like to return to our project objectives before we wrap up this morning. And those are really to promote economic growth and workforce development in the Powder River Basin and bring together this committed network of stakeholders. And as I mentioned earlier, we're wrapping up phase 1 of this Core CM project. But I also mentioned that one of our tasks is to develop strategies for technology innovation centers in the Powder River Basin. So that involves identification of the best path forward for progressing current and new technology innovation centers in the basin, as well as the evaluation of strategies to integrate these centers with workforce development programs. So I'd like to highlight just a few examples of ongoing technology development in the Powder River Basin. Trina talked about all of the great work going on at the Center for Carbon Capture and Conversion at UW. Rare Element Resources has a DOE-funded demonstration plant to process rare earths from the Bear Lodge Conventional Deposit in Upton, Wyoming. The Integrated Test Center is a great example of an established technology innovation center for carbon capture and carbon utilization in Gillette. Ramaco Resources in Sheridan is a coal to products and rare earth element research and development center. And there are a number of other DOE-funded initiatives in the Powder River Basin, including mind-scale machine learning initiatives being developed with Los Alamos National Lab, as well as the project that Morgan mentioned, the National Energy Technology Lab pilot scale project to look at rare earth element extraction from coal ash. And that is being housed at the Wyoming Innovation Center in Gillette, Wyoming, which is a research to commercialization facility operated by Energy Capital Economic Development. So we want to make sure that we're integrating all of these technology developments in the Powder River Basin and make sure that we know about all of the other great technology developments that are going on. So again, we value your input in thinking about this strategic plan. Okay, it is my honor to introduce Senator Dwayne Ankeny as our first keynote presentation this afternoon. Thank you, Senator.
Thank you. I'd like to welcome you all here. If you're from out of state, be sure and leave your money in Montana. Interesting, and the staff and the University of Wyoming, perhaps Montana. My name is Ankeny. I served in a representative for 8 years, served in the Senate where I was chairman of the Energy Committee in the Senate. You know, I went home during my break, my first session in 2007, and I gave an update to the people in Colstrip, what goes on in the legislature. And they said, what's it like? And I said, well, power plants in Colstrip in the early 70s. And a friend of mine that I worked with asked me one day up to Colstrip, do you know anybody that's got a truck? And I said, well, yeah, there's a old cowboy down on just on the Cheyenne Reservation by the name of Jimmy Peppers. And he's got a truck, he hauls hay for people. So I said, well, let's go down there Saturday and see if he'll haul hay for us. Saturday morning, and pulled up in the yard, and there was these old trucks sitting over there, and there was a kid in there, and he's just up and down screaming and jumping up and down. And I said, hey, Jimmy, what's wrong with that kid? He goes, well, he's got 3 or 4 fingers shut in the dirt. Figured out directly. And the legislature is like, they're jumping up and screaming for the first part, but they'll figure it out directly. So with that, you're free to take a nap after lunch if you want to, and I'll go on with my presentation on mining history in Montana. And it's really not complete, but it's a pretty good overview of the activity in Montana. Has been exceptional. I mean, I don't know anything about critical minerals or rare earth elements. I'll be an expert. So I want to thank all those people that spoke this morning. Called me and talked to me about speaking here. I'd already registered. I said, hell, I don't know any rare earth elements or any of that. And they go, well, talk about Montana. So I was somewhat relieved at that. Every type of any kind of, well, all wealth comes from the earth. all type of extraction, whether it's coal or gold ore or copper, whatever it is labor intensive. It's good, high paying jobs. And I love putting people to work. The opportunity to keep our people, whether in Wyoming or Montana, in state with a job that pays a living wage. Not the old, they started mining copper and then they alloyed it with you guys out there way more. So let me get out there before you critique me on this. They alloy tin and other elements to make bronze. Really started, the metal mining, then it was gold and other minerals. But so that's my ancient history. Let's get to the century. Coal was first discovered by William Clark, or first discovered in Montana by Williams way back. Rosebud Creek runs into it. And that is only about 30 miles as the crow flies from Colstrip. So coal mining or coal in a long time. In 1862, gold was discovered in Grasshopper Gulch in Bannock, which led to the big gold rush down in Virginia City and that area. Then some miners moved north to around Butte looking for gold. What they found was copper. And between 1880 and 1990, Butte produced 3 million ounces of gold, 709 million ounces of silver, 855 million pounds of lead, 3.7 billion tons of manganese, 4.9 billion pounds of zinc, and an incredible 20.8 billion pounds of copper. Now that was just till 1990, and they're still mining copper up there now. So Butte prospered from all that mining, and so did the oldest profession. Moving to the 1950s, there was activities in uranium mining in Montana. There was a lot in southwest Montana. Yeah. There was mining in the Boulder area up in Helena and Butte. And then there was a lot of claims in the Prairies, which is about 40 miles southwest of here. You could, when I used to go shafts, that kind of dwindled out in the early 1960s. And I believe a lot of it was due to regulations and how to process the uranium ore. And I don't know when they started in at Stillwater, but I believe that originally it was for chromium. And then early 70s, they found a lot of palladium and from up there. And that mine is still going today. In fact, there's buses leave out of here, out of Billings, several other places, and take the crews up to that mine. I mean, it's a 2-hour ride. But the wages, the conditions up there, I've been in that mine, in and out of that mine. Me and my buddy Jimmy Keene did a thorough tour of that mine. And those underground miners wouldn't do anything else but be an underground miner. They love what they do. Coal mining in Montana, the earliest commercial coal mining was late 1800s, and they hauled that coal from there to Butte for the processing of the copper that they was mining in Butte. Roundup, just north of here, was founded in about 1908, and in 1950 that was underground mining. Opened back up as the coal company, Bull Mountain Coal Company, and they still underground coal there. It's a very high BT coal that's exported to Japan. Bear Creek Coal down south of here, just east of Red Lodge. They opened in 1906 and operated until about 1950, but in 1903, they had the Smith mine disaster, which was one of the worst coal mine disasters in the history of Montana mining. You can still go up there. It's very interesting to go through that area, and it tells about how many miners was killed in that disaster. I think there was 73. And, you know, the thing about Butte and Red Lodge especially was the ethnic diversity. I mean, a lot of Eastern Europeans migrated and came over here, and they knew how to mine, and they went to work in those mines. So even today, in Butte, you'll still see sections of Butte that's Slavic or different ethnicities that are in those areas. So long before it was the in thing to be diverse, these coal mines or these underground mines brought diversity to Montana. This brings us to the open pit area era of mining in Montana, which there was East and West Decker, provided coal to Detroit Edison, Big Sky Peabody mine just south of Coal Stream mine, which originally were Montana Company, and the Spring Creek Coal Company. And what all these mining activities have in common is they pay on an average of 3 times the state's average wage. They pay good money, and they bring a lot of young people to the table for work. In the royalties in these mines, federal government brings in millions in royalty payments. Through 2022, there was about $2.5 billion in federal royalty payments. 50% of the federal royalty payments stay within the state, the same in Wyoming, I'm sure. And the total federal royalty payment was 1.3 billion, state 2.3 million, private 7.3 million, or 739 million, and indigenous 200.3 million. The important thing to remember that most of this they pay stays in the state, excluding the federal royalty. The state and the rest of it, that all stays in the state to help our economy. I was in 2019, I was chairman of the Appropriations Committee in Montana, and it's just, I always said, and I made sure everybody knew it, every dollar Montana was spending had a little bit of coal dust on it. And so through in 2022, they paid a total of 96 million in wages, severance tax since 1975, 2.4 billion. 1.2 billion of that stays in a permanent trust fund in Montana, and that's it's more than that today. Additional taxes, I mean, on coal, nothing else. I don't care whether it's liquor, tobacco, what it is, nothing else is taxed like coal. It's almost like a punishment for coal being what helps the state prosper. But in addition, they pay gross proceeds, resource indemnity taxes, federal taxes, property taxes, and personal income taxes. So, I mean, Montana's got a 15% severance tax on our coal. It had a 30% severance tax on our coal until 1987, when a bunch of coal miners, 450 at one time, was in the Capitol in Helena protesting the 30% severance tax, and we managed to get it lowered to 15. We were shooting for what Wyoming has, but we settled for 15%. So that kind of took us out of the major coal market at that time in the early 70s, that 30%, but we did get it down to 15%. Mining has brought prosperous times to many cities and towns in Montana, but most of all, through the 200 years of mining, that economy, those wages paid, has put shoes on many a babies. And for every miner, there are 4 jobs indirect that are created because of mining in Montana. There are critical minerals in coal and in the byproducts of burning coal. Hopefully our coal industry will see a resurgence of activity through the search for minerals for this mineral. In any case, the extraction, when it does happen, and process of those minerals will have a strong economy in those areas where those rare earth minerals and elements are found. I'm almost done. Hang with me here. And I want to thank everybody for listening. I don't know if it was that interesting or not. And I want to really thank you for not throwing anything at me. I'm used to speaking to a bunch of coal miners, so you got to know how to dodge. I am a coal miner, and I'm proud of it. I can only hope Montana will get on board on the bandwagon and work aggressively with the University of Wyoming in this valuable research. And thank you everyone for listening.
Thank you very much, Senator Ankney. It's my honor to introduce our next keynote presentation. This is John Williams, who is the mayor of Colstrip, Montana, and he will be speaking to us today about Colstrip, yesterday, today, and tomorrow.
And thank you, staff of the University of Montana. Get to follow the senator and the Jimmy Peppers story. I could tell that story, but I won't. But I could tell it because I've heard it before. Thanks, Senator. Senator and I have a lot of things in common. Not only we're from Colstrip, but we've put a lot of years in for public service, and we've also served our country. So thank you, Senator. I appreciate the opportunity to visit with everybody. You know, when I was first invited to speak, I had kind of similar I shared the story with somebody and I said, the University of Wyoming wants me to talk. They're having a conference on carbon or rare earth elements. And this person said, you don't know anything about that. And they're right. I don't, but I do now because of this morning. So I appreciate the opportunity to hear what the University of Wyoming is doing. It's such a positive thing that you are involved with. And perhaps some of that will reflect into Montana. But you've asked me to talk about Colstrip. And I take a real pleasure in doing that because I've got a passion for our community. A passion for it, and I know a lot of the history because of my involvement with Colstrip over many, many years. I've lived there for I think about 54 years. I came to Colstrip at the beginning of the construction of units 1 and 2. I came with another Montana Power Company employee who was the manager of construction. I was responsible for the accounting and he was responsible for the construction, and I've been there ever since. And it's been a blessing in my life to have experienced that. This last year, we celebrated our 100-year centennial in Colstrip. And that surprises some people. 100 years? In mining coal? Yes, over 100 years we've been mining coal in that community. Actually, the beginning of the mining occurred in around 1917 when they did an exploratory work. They were looking for a source of coal for locomotives. The Northern Pacific Railroad was looking for a source of coal. They were receiving their coal, and the senator mentioned Bear Creek, that Red Lodge area. They were receiving coal at that time from that area, and they were looking for a cheaper supply, more readily available supply of coal. So they did their exploratory work, and then in about 1924, they opened up the coal mines in Colstrip and built a camp to house the workers. And that was the beginning of Colstrip. And they mined about 1 million ton a year, providing coal for the locomotives over the next 30 years. And then when diesel came into play for the locomotives, and this was about 1956, then the railroad switched to diesel versus coal, essentially a ghost town, until 1959, when Montana Power Company purchased Colstrip. They purchased the town and the mine and all of the mining leases that were in existence, plus the equipment, with the intention at that time that they would develop that coal for the production of electrical energy. Those plants were first initiated, units 1 and 2 initiated the construction on those. It was in the winter of none on them in 1971. Montana Power Company involved its cell plants. They built units 1 and 2 and units 3 and 4. Montana Power Company was it's the same time Montana Power, and the senator mentioned that they created the mining company of Western Energy to mine the coal. That was a wholly owned subsidiary of the Montana Power Company, and that was created in 1967. And they began mining coal for a newly constructed power plant in Billings. So that's the day that modern coal mining and power plant generation began that year in Montana. And I've said it before that there's no other industry that can claim the credit for the prosperity in the last 50 years for the state of Montana as has the mining of coal and electrical production of energy as a result of that. And we've been blessed as a state because of that. Montana Power owned all of the holdings within Colstrip. So we were a company town. Colstrip was a company town. It was owned by the company. And through some transition of change for downsizing and reorganization, there was a group of us within the city, within the community, because of the companies wanting to remove themselves of responsibilities of town operation and town ownership. We got together and talked about becoming an incorporated community. And as a result of that group of residents, there were about 8 of us, we put it out to the community to consider going forward with an incorporation effort. And we were successful with that. We incorporated as a community in 1998, and there was a group of us became mayor. I became mayor in 1999, and we set up our city government. As a result of that, to get started, we borrowed $60,000. We went in debt to become a city. Financially, we're very well prepared as a community as a result of that effort that we put into place way back when. And we are very well prepared for the future. We don't know exactly what the future will be. And I've identified it. That's one of the things that we're going to be, that I identified as a topic in my speech, or my talk. But I think what I'm going to do is, rather than have me do it, I know that Jim Atchison is back here, and he's going to be talking about that with with the group that he's involved with. But we, at the same time that we incorporated, there were 2 years prior to that time, a group of us got together and created Southeastern Montana Economic Development. And Jim is here today, and he's going to be visiting with you, and Jim is the executive director of that. We've had a lot of challenges over the years as an incorporated community, but we've also had a lot of opportunities. And how do we prepare ourselves for the future as a community? We took this community and we worked to improve upon the quality of life for our residents. And we've been very successful as an incorporated community to be able to do that. I've had the blessings of being a part of that over a lot of years. And we're positioning ourselds now that we're very well prepared for the future, whatever future that is that will be out there in front of us. Had a lot of controversies on issues associated with negative aspects regarding coal and power production that we've dealt with. Matter of fact, there was most recently, there was an article in the Los Angeles Times, and we had an opportunity to visit with the journalist, Sammy Roth, the Red State coal towns still power the West Coast. We just can't die. Reference there is the coal strip. And my response back to Sam, we're not going to die. There's a lot of opportunities out before us, and we plan on moving forward with that. And the things that you folks are doing as an indication, those are positive things that are on the horizon. One of the things that I jotted down some time ago, and I will close with this, exactly how coal strip and mine in progress with many challenges. However, I am convinced the future, our coal strip future, right, and many challenges and opportunity. Thank you, Aaron. I appreciate the opportunity to visit with you and everybody well in this adventure that's before us in the University of Wyoming. You're right up there, so thank you for that.
Thank you very much, Mayor Williams. We will move right into our first discussion session now and take a break after that one. So moderating this session, we have Fred McLaughlin, who is the director for the Center for Economic Geology Research at the UW School of Energy Resources. Panelists, we have Trina Pfeiffer, you met learning, the director of the Center for Carbon Capture School of Energy Resources. We have Gordon Criswell, who's the director at Talon Energy. We have Bradley Layton, Neodymia. And we have Morgan Evans, who you also learning, who is the lead environmental specialist. And so this panel will cover value-added uses for coal and coal waste streams. And I'll pass it over to Fred.
Thanks, Aaron. So it's my pleasure to be here today to sit with these panelists, and even more so, I get to ask the questions and not get put on the spot. So we are missing one here. Can we get the extra microphone just so it's easy to pass around? So you've got to meet some of the panelists already. We've had both Morgan and Trina present to us this morning. So Bradley and Gordon are going to have a few slides to share. So here's what we want to be interactive. So we'll save some time at the end for questions from the audience. Hopefully we'll save some time at the end for questions from the audience. And of course, this is value-added uses for coal and coal waste streams. So we'll try to cover both of those topics during our discussion here. And I hope it is a discussion. So first off, we'll do some introductions. And Kyle, I can't quite see who you're loading up here. Can you load Bradley's first since he's excellent? I'll pass to you, sir.
Okay. And so I think I have more slides that we can really cover, but again, my name is Bradley Layton. I was previously on the University of Montana faculty directing the energy technology program. That program no longer exists. I know there's some interest in getting it back going, especially in light of the discussions we've been having, but since 2017, I've been in private engineering practice. So the logos that you see here on the screen, Neodymia was founded in 2019, and we could just, well, I guess I can kind of see that. And Montana Critical Metals, which also has a focus basically on extracting metals from coal ash, was just recently founded. So I will, okay. So as we know, there's tremendous value in the ash. I prepared a few slides that just sort of show how much. And, you know, we know this is not just a Montana problem, but also a global problem. So some of the subsequent slides show, you know, just how much coal ash, again, I don't think I'm really controlling this thing. Yeah. Weird. Oh. So just doing a commodity comparison, you know, the average value in these metals, it ends up being on the order of $48 per pound. You know, we talked about a lot of metals, and we've gone after and see here is really just the tremendous amount of money excavate one of the ponds at Colstrip. And, you know, it's what we're really focusing on is, hey, while that's being excavated, can we actually go after some of those metals? We have a beneficial use designation in place that Gordon and I have been working on, and with any luck, we'll have that approved and start focusing on a few metals, especially gallium. And so, of course, it starts here in Montana. As we know, we've also had some recent interest from foreign investors, in particular India. I know someone was mentioning aluminum. Certainly, there's some money made there. Just a little shot of me in the lab saying, yes, we've actually at lab scale. Here's a shot of some of the we've actually gotten from the actual strip saying it's there. The next step, of course, is just to say it's profitable, and we think the answer is yes. Next steps, we've got a lab in Missoula. We have our eyes on an abandoned paste. Could do this at scale in Colstrip. We have a pending Department of Energy grant right now, $5 million that we're hoping to hear back. And of course, thanks to the University of Wyoming and all their assistance. So we could cover the economics in more detail. Funders thus far.
Yeah, thanks. So I'm Gordon Criswell. I'm the Director of Environmental and Compliance at the Colstrip Power Plant. I work for Talon, Montana, which is basically Talon Energy. I've been at Colstrip for 45 years. Senator Ankeny, Mayor Williams, and Senator Ankeny, I'm the youngster. So a long time, a lot of great times at Colstrip. I think both you guys did a good job talking about that. So really enjoyed it. Okay, I can just keep talking then. So just a little bit on the Colstrip plant. Mayor Williams kind of covered. Basically, there was 4 coal-fired electric gen. When they were all 4 in production, it was the second largest coal-fired electric generating facility in Mississippi. I think the Four Corners units were the only ones that were bigger. Since 2, which were the older units, went into service in 75, have been shut down, permanently retired in January operating. Units 3 and 4 produce 1,480 megawatts of electricity. That's enough to serve about 1.2, I think, each year. So it's still a pretty significant source of electricity for Montana and the Pacific Northwest. There are 6 owners of the Colstrip facility, several of them in the Pacific Northwest. I'm just going to keep going through. That's no problem. Yeah. Just a couple other notes. You know, a lot of coal plants, especially in the west or in the east. So there's a shot picture of the Colstrip facility, all 4 units. Again, it's a real nice facility. I told people when I graduated from Montana State University, chemical engineering, I went to work for 3M. And I came back after about a year and a half because I wanted to live back in Montana. And I tell people, as an engineer, I don't believe there's a better job in the state of Montana than working at a facility like this. That the size of the equipment here is incredible. If you haven't been through a power plant that's this big, you should take the chance to. And then Colstrip runs a lot. You know, the capacity factor last year was 84%. And what that means is the unit ran at that percentage of its rated capacity for the year. So that's pretty significant. A lot of your coal plants, especially in the east, are only running anywhere from 5 to 20% capacity factors. So Colstrip's certainly needed and a big source of electricity here in the Northwest. About 250 employees work at the plant, and a similar amount work at the mine. I know I don't know if later on the mine folks might talk about that. I know they're here, but it's a mine mouth plant, so we take coal right from the mine there at Colstrip. Just a lot of this has been covered already. I just referenced this DOE report back in 22 that basically said in quantities that could support large scale production, and that of getting those has been proven. So that was a report they sent to Congress. I know a lot of this has been discussed in different ways previously, but at coal strip, you just units 3 and 4 operating now, we generated about 600,000 tons of coal ash a year. And with all 4 units operation and the ash that was put in the impoundments there at coal strip, there's about 30 million tons of coal ash available to process. And as Brad mentioned, we have done some bench scale testing for rare element extraction at coal strip, and those results are positive so far. And then I think I'll just end with a slide that shows the critical, some people call it ash pond, but I'd like to think of it as a critical minerals ore deposit. So with that, that's all I have. Thanks.
Fantastic. Marketing is important for sure. So are you guys going to join us back? Okay, just checking. Well, our other 2 panelists have had slides already, so they've done kind of an introduction on their work, but please feel free to introduce yourself one more time.
Okay. All right. I'm Trina Fike, Director for the Center for Carbon Capture and Conversion at the School of University of Wyoming. A mouthful. Anyway, our coal to products work, I focused on do have some high value products too, but trying to move the high volume products to commercialization is our focus. So I'm glad to be here.
Hi, everyone. Morgan Evans. I work for Battelle, independent nonprofit R&D organization. We have and always will be a not-for-profit organization focused on research and development in a number of areas. And critical minerals is one of them. So I lead a team of mostly chemical engineers and chemists working in that technology development area for critical mineral extraction and processing, as well as recycling of critical minerals.
All right, thanks, panelists. So just to summarize, we have somebody working directly in the coal industry, and then we have some research panelists that are focused on PRB coals, kind of regional around and site-specific coal ash. So I'd like to start following up on some of the talks we actually gave this morning, you guys. And Trina, I think I'll start with you if that's okay. Can you tell us what a few of the unique physical properties are of PRB coal that makes it a better resource for some of these endeavors? Again, coal utilization, and I'm going to pass to you to other, aside from man-made materials. So
Yes. So PRB coal is unique, and it has several things going for it. It has low sulfur content, so that helps with cleanup. It has a high oxygen content, helps with chemical, basically manipulation in order to make certain products. So that's really good for it too. In the way that we do have very low polycyclic aromatic hydrocarbons. Those are the things that you don't want in your products. So very low or non-existent in the products that we have. And the other thing is the cost. The cost is very low. So those are, I would say, are unique to PRB coal.
fantastic. Bradley, you want to follow up on that? Looking at ash.
Sure. So when we first started looking at this, there was a study that came out of Duke, and they did a comprehensive study across the country that really looked at the ppms or parts per million across the different basins, Illinois, et cetera. And, as we hoped and found, the parts per million were in that economic sector. And if you recall that, the acronym for this meeting is the critical metal, higher than most of the other coal basins in the United States in terms of gallium. So gallium came out quite high, and that's what we wrote our beneficial use designation for in coal strip initially. I mean, our goal was really to get as many of these metals out as possible, but you can't necessarily have it all. So we're looking for, at least for investment, metals such as gallium, as well as germanium. If you've been following the news, you've probably seen that China's even said, "Hey, we're cutting you guys off on those two metals." So I've had the opportunity also to go to DC and talk to our federal delegation about this, and they're very supportive. So that's where we're focusing right now in terms of things that are both supply chain critical as well as plentiful here in Montana. So
One there, I'll follow up with Morgan too, because you've worked in other coal basins, obviously. So, you know, what are some of the things you'd see that make PRB coal a little unique and maybe helpful in this realm?
Yeah, so Battelle worked on project several years ago doing extraction from Appalachian Basin coal ashes, and we had to develop like additional pre-treatment step just to, you know, treat the very early stage of the coal ash because of the high silica content. So we have to do an additional like caustic leaching step before you do any of the traditional processing, and that obviously adds a lot of cost, a lot of, you know, capital equipment to deal with, you know, an alkaline kind of system like that. So I know just from, you know, comparison that the PRB coals have a lot less processing required, and I think there's a huge advantage there from being able to, you know, stand up any kind of processing facility.
Excellent. Well, we'll take advantages when we get a chance to get them. So, the other thing I'll put forth from the university perspective, I think our region, it's much easier to approach and work with industry. And it sounds like you have existing agreements already in place with some of these, but what's your guys' perspective on, obviously, your programs like this, or being able to work with your neighbor, kind of advancing it?
Yeah, a couple thoughts there. One is when we first started talking about the beneficial use of the coal ash, one of the main drivers was the avoidance of a landfill that we were going to have to build under a federal CCR, coal combustion residual rule. And we were hopeful that we could have some process in place, some kind of beneficial use of our product and avoid that. That's probably not going to work out just because of the timing and how long it's going to take to develop these kind of beneficial uses. But then we started looking more at the economics of it and started working with Brad and his company, and found that, you know, there could be some economic value to this also. So we continue with bench sampling to try to confirm where that might be and just what it looks like. Still a long ways to go. But the other point I wanted to make was the state of Montana, the Department of Environmental Quality, is very supportive of beneficial use of this waste product. And Brad referenced a beneficial use determination process that they have. And so we've worked through that with them to try to identify how could this process work, what kind of environmental impacts, if you will, there might be from it. Optimistic that there's opportunities here and that there's good support, and hopeful that we can be mining our ash ponds someday. That's going to be the case.
Well, thank you. We appreciate the support. I know that does research. We have some colleagues here from UND, ERC. I know they do that as well. So is Montana. Because we're talking about coal. Let's go with coal first. What's happening here outside of the PRB? Is it coal over the next decade or so? What do you think the low hanging fruit would go?
Well, okay. Talking about coal in general, the East Coast has content. They have an anthracite, they have bituminous coal. Now they're focused on high value, like the carbon fibers and those types of things. A very big part of what we're going to see in the next decade. Things are going to be emerging there. On our end, on the west side, I think what we're doing as far as the high volume, I think the asphalt is going to actually really become quite prolific, and I think is something that we all, I mean, it's more and more as the years go by, the petroleum asphalt is going to become harder to find, and I think that's just going to be something that we're going to also think that building materials, there are a lot of people working on building materials. I think in the West here with our subbituminous coal, we have an advantage over our eastern folks over there, just because of what I was talking about with our PRB properties that we have. So I think that's also going to be some emerging technologies in the next decade, very much so.
All right, I'll go back to come up a couple times. I'm sure this is on everybody's mind. And I don't know if this is a question we can truly answer, but I'm going to ask it. What are the minimal concentration of REs that make extraction economical? And is there a minimal amount or a maximum amount? So what are the restrictions there? And you look geared up.
That, you know, maybe 6 or 7 years ago, the DOE released, you know, kind of a standard that 300 parts per million in coal resources was kind of the cutoff for it. Someone also commented on that being there's a lot of reasons for that. One being that depending on your economics could look really different depending on your thing and how expensive your process economics are. Looking at things like your reagents, treatment steps you need, how much you're going to have to spend removal and disposal, shipping and transport costs, things that all add up. And so the process economics are not that black and white. And then I think too, we also have the market side of things where we don't know what the market's going to look like in a week, the geopolitics that are involved. And so right now it's really hard to find a buyer producing rare earths, but that could change really quickly in the next several years. Think about, we say 300 parts per million for coal-based resources, but there's some feedstocks like acid mine drainage that because of the ability to kind of have more of like a passive treatment approach, you could have parts per trillion rare earths and recovery can be economical. So again, I think there's kind of an asterisk on that 300 parts per million.
Right. Just to follow up on that, maybe on two fronts. And one thing I kept hearing this morning, which really resonated, was high volume versus high value. And we had been discussing with an emerging company that said, gosh, we could more than likely turn all of that coal ash into concrete. And so we haven't completely given up on them. They were a little bit intimidated by this bud process. I think ours is going to be approved very soon. I think maybe once that's approved, we'll reapproach them and said, hey, we'll write your bud for you. And it's not that scary, it's just the DEQ. But to the other, in terms of what's the minimum viable product, if you will, we did a lot of those calculations. And there's an old saying, scale or fail. You're not just going to do this in your garage and be profitable, but we found able to verticalize the gallium in terms of getting it to a product that could be directly used by the semiconductor industry, for example. Just adding one more step, your sort of dollar per ounce, your dollar per unit volume goes up 1,000x, for example. So if we could do some of that in coal strip as well, I don't think we're talking about a chip fab. The CHIPS Act was just passed. There is a big emphasis now from the federal government to bring a lot of that, back to the U.S. from Taiwan. So get some of these fabrication plants and do that at other places in the country. But if we could supply a high value chemical from this gallium that I mentioned previously, the numbers for us worked out to be 3 tons per day. And so just yesterday, Gordon and I were looking at this, and he's like, well, yeah, I think my truck is about 200 tons. And so like, okay, I think we'll just use a Ford pickup or something, three tons. I think just for to get to that scale, at least where it's economical for just gallium. I think really we'd love to pull as many of the metals out as possible. And I showed you kind of half the periodic table there already that we'd ultimately like to go after. But that's where we are with sort of high volume and high value. So that those are both, we're looking at through both of those lenses.
I was just going to add to that. I think you're highlighting a really important facet, that there are certain critical minerals that are going to be, in the short term, easier to kind of stand up than others. So gallium might be one of them. Lithium might be another, where we actually have American buyers for the mineral that can go right into American products. So.
Yeah, that's a good point. So I got a question there, a follow-up that's kind of more focused on the more commercial side of our panel a little bit. Aaron mentioned this morning that some of the funding for these research points are generational. We'll likely not see this again. Morgan, I think you said buckets of money. But are you guys seeing, different commercial drivers in terms of economics? Do we have, coal plants or coal miners that are going to put in like R&D segments? I'm just curious.
Yeah, I'll start. For my company anyway, our focus is on our core business, and that's making electricity out of coal. What I see is we're a little bit hesitant to put a lot of money into research. Typically, we don't do a lot of research. We rely on other folks like what you guys are doing to help develop that and move it along. So I'm not sure that that I'm going to see, or that we're going to see a lot of support. And I'm just speaking for Colstrip, between my company and the other owners at Colstrip. I just don't see that they're going to be putting that kind of research investment into this. So we're going to have to look for others to help us get there, whether it's the government or whatever. The other thing I want to add, kind of follow up on the previous question, you know, we're talking about critical that other beneficial uses from the coal ash. And I think our ultimate goal would be get critical minerals out and then find a way to turn that, what's left over, into a beneficial product, like a, you know, a building block material or a green cement. I've heard of other products that companies can make. So I know there's a lot of private companies out there doing research and trying to develop this. So I think that's where it's going to come from.
So, and like I mentioned, we have been talking with companies in the United States who say, yeah, we could go ahead and buy, 30 kilograms of gallium from you per month right now. And I think I might have mentioned also, some investors from India have said, we have issue here in India, and we've got $100 million burning a hole in our pocket. If you can come help us. So we really need to get our feet under us, in Montana, prove this technology first. But so there are investors interested, and I think Jim even mentioned a few. Happy to follow up with, and I've come in Mia, diving into some of these business has been a little bit rough on me. So if anybody wants come on board as a negotiator, happy to talk. It gets kind of ugly in academia, but those business can be pretty slick. So look, possible things.
Some of the stuff we heard today, obviously we need market drivers happen, and I think it'd be interesting for Corsium even to hear from some of those people that might make those investments. I think sometimes we take other things for granted, and even the regulatory hurdles of using coal waste or even coal for doing some of these value-added benefits. I mean, obviously right now it's leased to make electrons or steam. It's not leased to make REs. Do you see challenges there if we're going to actually try to broaden, this kind of resource in the basin?
Yeah, I think there's going to be challenges from environmental folks on anything related to coal ash, and so forth. But I will say in Montana, as I mentioned earlier, the Department of Environmental Quality has been very supportive. The Department of Commerce, I know Cannon's here, has been very supportive to help us find ways to beneficially use our waste products. From an actual regulatory standpoint, at least where we sit right now, we have this beneficial use determination process that DEQ has put in place, where they're going to be reviewing the whole process, how it's done, what potential impacts there might be. And once they give approval of that process, then supposedly that process can move forward. And I'm still trying to clarify with the regulators, with the Montana regulators. Well, so does that mean the beneficial use determination process is a permit, or is there going to be a whole nother level of permitting? And their initial indications to me were that the BUD would be the permit. I'm hopeful that that's the case, but honestly, I'm a little skeptical about that.
Yeah, and I think sometimes it can be a little bit of a moving target. I just heard even on the radio coming over here that no amount of lead is safe, and it's just like, well, gosh, how good is your machine for detection? And there have been issues in the past. A friend of mine used to less arsenic back in the river than we pulled out of it in the first place, and so sometimes there's just more background metals than what the regulations require. So it can, but as Gordon was saying, we've had good collaboration with close to getting our beneficial use designation approved, and then it's just a matter of running up the funding and the workers and see what we can do there.
We really appreciate first movers taking away. So one of the interesting things I want to discuss about Corsium, of course, is to develop regional tech centers to help push us forward. Aaron mentioned a few that already exist. Some are on the commercial side. Ramaco is here, for instance, and some are state supported in Wyoming, like the ITC and the Wyoming Innovation Center. I'm curious, specific tech centers would you guys?
I go ahead. Do you want to go ahead or? Okay. Well, one of my goals here was to look for talented chemists, because I think we're low on that. I'm happy to be sitting next to at least two of them here. So that's what I'm looking forward to. And I think I'm also going to have a visit to Laramie soon, and was just offered a tour of that facility there. So and a lot of times I'll sit in these business meetings, and sorry if you've heard this joke already, but these arguments will come up, and I'll be like, hey, what do I hear there in the background? It sounds like it sounds like a billion Chinese laughing, because we'll get in these arguments with each other. It's like, meanwhile, we're having these business arguments, but China, as you saw with some of these graphs, they're moving ahead. So I look forward to collaboration among my fellow Americans to put our heads together and solve this problem.
I want to agree with the sentiment there, just about increasing collaboration between different sectors and industries, right? Like, and I think forums like this are great for that, where you have academia and nonprofits and industry coming together to try to figure out how we can all pitch in to solve kind of the problem, and facilitating some of those collaborations. But yeah, I think what we were talking about this morning with a lot of the resource assessment and the technology development and things like that, like starting to link those pieces together, and figure out, how can we really kind of shore up kind of the full supply chain from the PRB feedstocks all the way to the value added products made from coal, like Trina's working on.
So disregarding, we're gonna follow up, disregarding the market, let's pretend that didn't matter.
Yeah.
Do you think extraction's the place that's still the most limited? Because that was just a conversation we had recently.
Could you clarify what you mean by
How
extraction?
hard it is to extract and process still, the maturity of those kind of technologies.
Yeah, I wouldn't say that I think that's the biggest bottleneck. I think that can be done, and certainly too, even building things to pilot scale or above, and then being able to bring in process improvements with your existing capital. So like one example that I talked about earlier was, solvent extraction is been done for 100+ years. It's not new. It's people know how to do it. But there are process improvements where you can use the exact same capital, but drop in different different solvents and different extractants. And so I think process improvements can really help with lowering the cost of extraction and improving extraction efficiencies and things like that. So I don't think that's necessarily the biggest hurdle. Maybe I'll open that up to the other panelists. I think that's one challenge, but I don't think that's the only or the biggest challenge.
It's true. In fact, one of the extraction methods that we were hoping to do, it's solid phase extraction. So rather than these giant solvent vats, you're moving individual molecules through a high surface area, sort of a spider web lattice. And this has been demonstrated. It's a patented process. But it's never been tested at scale. There's a 3,000 gallon tank that we'd love to run this in, and it's either going, it's like one of these things. It's either going to go really well or fail spectacularly at scale. Something, and so, but there's only one way to find out, and that's kind of where we are right now with our solid phase extraction that we're hoping to put into practice. Because as Morgan said, it's big. We think there are cleaner, faster ways to accomplish the same goal.
I was just going to say, I think separation is probably a big hurdle, the separating of each individual or groupings. I think that's going to be a big challenge. So
that's obviously part of the conversation here. We kind of come to hurdles and barriers, but there's a ton of federal entities working on this, federal money, but they don't seem to be cooperating all the time. Do you guys have views, thoughts on that? I mean, again, CORSIEM is a vehicle where we can develop a strategy to say, if we were a little more efficient here, we might work better. Do you guys have personal insight on that at all?
Yes.
Okay, if you want to go first, it's okay.
Well, so as I mentioned previously, I'm very lucky to have been working with a very talented chemist earlier, and to hire another well-known chemist. And I invited him to the meeting. He said, oh, you're going to that meeting? Sorry, I'm part of the Alaska group, and we're competitors and all this stuff. And so again, I get back to that sort of billion Chinese laughing. It's like, no, guys, come on, we're one country here. Let's get together and solve this problem. Because I think and I guess in some ways that's the American way. It's the, it's the cowboy spirit and hey, I'm out there, I'm a lone wolf and I'm going to get this done on my own. But maybe it's time to, realize, sort of, hey, this is a, Manhattan scale project. So.
Yeah, I was thinking the same thing. I think you're speaking more to maybe outside of the government entities that Fred's talking about, meant to foster improvements and innovation so we don't stagnate. But I think we're so many voices in the room, and everyone wants to protect their trade secrets and their intellectual property, which is, it needs to happen, right? But I think at the end of the day, you have further if we could work together more, especially from a technology standpoint. But I think, yeah, if you've been tracking federal funding at all the last 5 years, Department of Defense kind of has their own agenda as far as what they want to fund and in research. The Department of Energy obviously has a lot of programs and things that they're looking at. EPA has started to fund critical mineral based work. NSF is interested in getting into the game as well. And there is some interagency work. I know that USGS and EPA and DOE have been trying to have interagency working groups. And I don't know what the solution is, but I do think, having some, some kind of collaborative efforts there could be helpful. Again, my own ignorance, I don't know what the best solution is, but I do think that it's splintered kind of in multiple sectors.
Interesting. So I have a question, actually more interactive for the audience, so we don't all fall asleep after lunch. But with respect to value-added benefit of coal, who would be willing to build a coal house? Contact Trina. Some of the coal mines, you guys need to rebuild any buildings? They got one buyer there too, Jim Ford too. I think we got to just ask every audience member. Yeah.
There's a lot of people that want these bricks, so yeah.
Yeah. Oh, yeah, I'll 50.
Oh, yeah. No problem. So, so the asphalt I'm sorry.
No, go.
Okay. So the asphalt binder, that they have in the refineries is the very bottom stuff. It's the stuff that you don't crack at the end. It's the bottom stuff, and it's not worth much. I mean, that unless you bring it up and crack it some more. So that's where the petroleum binder comes from. And I don't know the cost of that. I do know the cost of binder itself when you're going to mix it with the aggregate to make the asphalt is about $1,000 to $1,100 a ton now. And I also know that our process is right around $1,000 a ton, and we're young and we're going to drop the cost. So right now we're comparable. 5 years ago, we were not comparable because we were still $1,000 and it was about $600 or $700 per ton of asphalt, petroleum asphalt binder. So now that it's gone up so high, we're in that market now. So I think we can bring the cost down. I don't know the answer to your question on what it costs for the actual petroleum, as far as if you're comparing it to coal. I don't know.
I think there's also a question regarding uranium and thorium content. And yeah, it's non-trivial, but our separation technology, we do have some experience with that. And I think there was some discussion of nuclear in Montana. So at least there's a market for that as well, hopefully.
We've got another question still for the panel, and then we'll reopen to the audience for sure. So of course, we're regionally focused here, and I do promise we work with Alaska, though, Brent Sheets and those guys. And the other course, in Kansas, we do our best because it is supposed to be, we all pull ourselves up together. But for our region, and again, your personal take, would it be better for us to focus on high volume or high volume? High value or high volume?
I say high volume. And the reason I say that is our coal has less carbon in it than a bituminous or an anthracite because it's subbituminous. And so the high volume uses of coal, and for the other reasons I was talking about the PRB as far as the high oxygen content, the low sulfur, the PAH issue, and then the cost as well. We can still do high value added coal products with PRB coal. It's not the same as if you have a higher carbon content to start if you're going to be making things like carbon fibers and things like that, that are really high carbon content. So that's what I think. That's why we're focused on them.
From an environmental standpoint, I'd rather see these waste products that are sitting in the ground in impoundments with the potential to cause environmental damage to be turned into a beneficial product that's safe. And the technology's out there. It just needs to be developed farther. So that's why I go high volume.
Right, just to tell a little story. I think the last time I was in Billings, we're sitting over here at Bernie's with the Talon VP, and he kind of gotten done with his meeting, so he's sitting there in his tattoos. You know, who am I going to pick? You know, someone's saying, and the answer is clear there. So, but and I think I heard someone say yes to. That's my answer as well. So thanks for that.
One more question. And again, this goes back to Corsium, and again with respect of your businesses to training to address, you know, coal and value-added coal waste products. What kind of, you mentioned chemists, Morgan, you've got a lot of, you know, people that national labs are, and just be interested what we should be focused on as educators.
I think he needs more chemical engineers, I would say, and mechanics. So that would be and metallurgical engineer, all these. Okay. You need them all. You really need them all.
Just too on visualization. I love the 3D room I was seeing. And I think a lot of times, you know, the math, but I think to get younger people engaged in solving these problems, I think just like the gamification of solving some of these problems, I think would go a long way, you know, towards incentivizing, you know, people who want to have that gaming experience, like, okay, you know, solve the extraction problem, ready, set, go, but, you know, make them play by actual laws of physics that you've programmed into your 3D game. So, you know, you sort of get you trick them into becoming chemists, I guess is my plan there. I don't know.
Everyone be a mile wide and an inch deep. I don't want to go to that. I do think more interdisciplinary and education is helpful as we move into fields like this, where you need engineers, you need economic geologists as well, and project managers and good people who can go out and talk to stakeholders. Such a variety of kind of different training, and that could be teams of people who are very disciplinary working together, but I think also curriculum, you know, and education, so that you have people who can kind of flex between different roles is important too. Again, going to the other extreme of having no one be a specialist, but I do think those roles are important.
Well, I know from the Wyoming side, we always need more people. That's the easy answer. Yeah, from all sides. So I'd like to leave some time for you guys, the audience on the spot, and we do one.
The question is, what steps for coal strip with ash to a beneficial use product? Yeah, so right now, probably the first step is for any beneficial use product or a waste product at coal strip is going to be the beneficial use designation process through DEQ. Then once you get that approved, then you could go forward. In the case of working with Brad and his group, the next step would probably be, I'm going to let him answer that. Yeah. But with other companies from beneficial use, you know, it's bench scale testing to prove out a concept. And then it's probably a small pilot to scale it up some. I'll let Brad talk about his plans.
So again, with respect to Corsium, let's try could, as a program, address beneficial use these different for the PRB. Would that help, you know, coal plants, everybody else?
Yeah, absolutely. If somebody wanted to step up with their kind of, if you know someone who's in the concrete industry here in Montana that just wants to piggyback on this, like I said, the one that we were dealing with previously, they're based in Alabama, and they just got kind of a head scratcher. But the technology has been published, you know, for building this so-called Roman concrete. So the Pantheon is still standing, and anyway, I'm hoping to get to their plant and figure out, you know, what they might have. But on the other hand, if we can find that high volume solution, I think the shovels are starting here pretty soon, and you know, Gordon's got a deadline of about 10 years to we can, crack this problem of a zero waste, zero landfill, 100% beneficial use designation, let's go for it.
Other questions from the audience? They volunteered to be up here for 8 minutes. Get them all you can.
You mentioned that the difficult part is to extract each element from the coal ash or whatever. What's China doing? They don't seem to have a problem.
You want me to start?
What's China doing?
So, I guess I'll start by saying that China has a really great rare earth deposit that are ion exchange clays. So they don't have to do much processing wise to be able to get out their rare earths. But secondly, there's not really much by way of environmental regulation or labor standards either. So that's probably the short way to answer that. I don't know if Bradley, you want to add?
And there's another deposit well known in in California, blank on the name, at Mountain Pass or something to that effect. And I know I have not been to the facility. I know the chemist I was mentioning previously has been there, but I guess it's it's private, it's difficult to get into, and so not exactly sure what's going on there, but so and I wish I knew what was going on in China, but some of this stuff is visible from space. I mean, you can almost see some of these processes going on, and I don't think there is much environmental regulation going on for sure.
And it's a good, and I think, unfortunately, off a little bit, if you would have done this at like 4:15, because this makes me want to go right to cocktail hour, because so that, keep that in mind, but we've done, we're a university, we've done historical studies of how uranium took off in the United States. Well, they promised to subsidize all uranium produced for about a decade at a set cost point. And, there are examples of the U.S. overcoming those market barriers, either to get new technology off the ground or to actually just take an India off the risk board. So that's one of the things that we'll strategize as part of this and try to report back up. Will anybody listen to it that might listen? I think we got time for one more. Well, the cowboy way is just to do it ourselves. I think that's what we're going to try to forge ahead and do. Now, I know we're at the end of the time from Dr. Phillips. I don't want to get her upset, but can we thank our
All right, I'd like to introduce our next panel. This will be our industry perspectives on technology development, and I'll add mining in there. We have a lot of mining experts on this panel. This panel will be moderated by Scott Quillinan, who's our Senior Director of Research at the UW School of Energy Resources. We have Greg Mauger as a panelist, who is the Director of Technical Services at Navajo Transitional Energy Company. We have Mark Ehrenbell, who's a geologist or geology manager at Navajo Transitional Energy Company. We have Dave Green, who is a project engineer at Western Fuels Dry Fork Mine. And we have Jerry Gillespie, who is the technical services manager at Westmoreland Rosebud Mining. So thank you to all our panelists, and thank you, Scott.
All right. Thank you, Dr. Phillips. And thanks everybody for hanging in there. I know we're getting late in the day. So we're going to try and keep it lively and told all the panelists here that you would be a great audience and have all kinds of questions and comments and suggestions. So be thinking about what those are as we're going through today. Order of operations here is we're just going to go down the line here and allow each of our panelists to kind of introduce themselves and tell a little bit about their background, where they come from, what company they work for, what's your favorite color. We don't have to get that deep. So let me hand the mic off here to the geologist on my left. Actually, the other thing I should point out, we do have 2 geologists and 2 engineers. So we've already segregated. Yep, we did put the engineers down that way. Yep. The geologists are on this end of the table. So we're going to start with our first geologist here. So let me hand the mic off to Dave Green, who is a project engineer at Western Fuels Dry Fork Mine.
Thanks, Scott. Like I said, I'm Dave Green. for 18 years, and except for 3 years as a pit supervisor, every one of those years, I've been titled some kind of an engineer or other. But like my boss had said when he hired me, it was a lot easier to teach engineering to a geologist. You wanted library, right? Yeah. Okay. Been doing mining in some capacity or another since before I even finished college. So since 1989. Capacities, I've done just about everything at Dry Fork Mine equipment. I did get to drive a haul truck for about a week before they sent me into the equipment, and they never let me touch equipment after that. So say something, but I don't know what else to go on about.
Tell us a little bit about the mine.
Dry Fork Mine was started in 1989, first coal shipped in 1990. Most of the reserves are owned by Basin Electric, built to provide coal to Laramie River Station in Wheatland, Wyoming. In 2007, 2008, they started construction on Dry Fork Station. First coal was shipped in April. First commercial coal was August of 2011. We are the sole provider of fuel at Dry Fork Station. We still provide to another. It's always back and forth between us and Wyatt Axe Mine in the basin. We had been up to about 6.4 million tons a year with now we're down to, I think, projected tons this year is 4.1 million. And we went down in 2020 down to like 50 employees up to 79. So our job and my experience mostly has been digging black rock out of the ground and sending it off to so they can give people electrons to use for their personal use. And with that, I'll pass it on to Mark.
So my name is Mark Arambell. I work for Navajo Transitional Energy Company. I've been with the company for over 20 years now. I am the manager of geology, which is kind of funny in its own right. I am the only geologist for the company, so I kind of manage myself most of the time, I guess. Primary roles and responsibilities, I more or less do all the exploration drilling in front of advancement of the mines. We have 3 active mines, 2 south of Gillette. One is Antelope Coal Company. The other one that's about an hour south of Gillette, furthest one south in the Powder River Basin. We also have Cordero Rojo Mine, which is about 30 minutes south of Gillette, Wyoming. And then we also have Spring Creek Coal just north of Sheridan and Decker, Montana. There's also a greenfield mine that we have. It's called Youngs Creek Mine, which is right on the border of Wyoming and Montana. Primarily, the entire mine's in Wyoming, though. Coal quality, update all the geologic models for all those properties. Resource and reserve reporting. Anything else really? So just kind of whatever needs to be done, I'll help out. I'll do diligence when it comes up, and I'm gonna have Greg kind of talk about the coal tonnages and a little bit more about the mines themselves.
You bet. Thanks, Mark. Yeah, with the NTEC, which is Navajo Transitional Energy Company, the key word in there is transitional. You guys probably won't know what that is, but a little bit about NTEC. It was formed, I think, about 2013 or 14. The Navajo mine itself, we do own that mine. It is a privately owned company that is directed by the board of directors, but its sole stakeholder is the Navajo Nation. So it is its own entity, but it reports to the nation. So transitional energy a little bit about that later on, but there's a lot of things that we're looking at, including the stuff that supports with the core, critical rare minerals, all that stuff. But it's an interesting proposition. Our fundamental process or project is to create value-added resourcing, manage it for the nation to create multi-generational solutions, which is a cool concept. So As far as my background, mining engineer from University of Idaho, which is no longer a college in regards to the mining side, but that's a pretty cool deal. 30 years with the company. And my primary responsibility is to help manage the engineering and the technical side for the entire company, for including the Navajo mine, the 3 mines that Mark mentioned. And we own a portion, about 8 or 9% interest of Four Corners Power Plant as well. And the helium. We also dabble into helium as well now too, so which is an interesting deal. So it's enough about me. Turn it over to you.
Hello, my name is Jerry Gillespie. I'm from Colstrip at the Rosebud Mine, Westmoreland Mine. 26 years with the company now, started out in gold. I think the comment referring to government interference kind of shut down the gold industry in Montana, somewhat trying to affect the coal industry. But graduated from Montana Tech, showed up in Colstrip, say 26 years ago, started out in engineering, transitioned into the production department. The majority of my time has been in production, various roles, drill blast supervisor, production manager, actually shift supervisor for a little bit. Most recently was maintenance manager, so I got 2 years stint in maintenance, was probably one of the funnest jobs I ever had lit, and just recently been asked to resume the role as the engineering manager there. So you've heard plenty about Colstrip. I get to work with the majority of these fellas here. I've heard lots of Dwayne stories, actually live right across the street from Mayor John here. So enough about Colstrip itself, but the mine, we're about 6.5, 7 million tons a year directly over the fence to the power plant. That's about it for me.
All right. Well, thank you, gentlemen. Appreciate the introductions. And Greg, from the University of Idaho.
Yes, go Vandals.
Well, they're going to be in Laramie in September to play the Cowboys in football. So you'll have to come down and watch them lose. But so for our first question for the panelists here, we talk a lot about, we throw stuff up on the screen and say, hey, look, here's this great source of rare earth elements. And you guys move a lot of dirt. You guys are in the mines watching this equipment work. And I'd love to just kind of hear your perspective of what do you think the challenges are from a mining perspective, as we're talking about rare earth elements and these little thin seams on the top and the bottom of coal seams. Can you just kind of give those thin seams or what challenges anybody want to take a swing at that one?
Yeah, so I guess in general, I think it's a doable thing. It's just going to be a change of a mine plan. If it's on on our main right now, it's not that big of an issue. I think the greater challenge, some of those unmarketable seams, that we're already wasting, that are above our main mineable seams. There's I wouldn't say quite a few, but there are definitely some seams out there that are just lower quality that we can't chip due to either high sulfur, low BTU, whatever it may be. That actually probably have some little better benefit for potential rare earths because they're higher in ash and lower in BTU. So there is some potential in that material fit. So if there's value added there for potential of anything, if it's rare earths or if it's carbon fiber or whatever it may be, I think there's definitely a benefit there. I mean, some of the challenges are going to be just an updating of the mine plan or maybe some more additional geotech constraints, on benching methods and that kind of thing. But it's all doable. It's just permitting and reorganization of the mining method.
Yeah, as far as on the mining side of it, back in the day, like Cordero Rojo, in the late 90s, we were producing about 40 million tons a year. Okay. Today, we're doing about 6 to 10 million. So that being said, back in the day, if you were saying, hey, we wanted to go after these thin seams and really try to separate, it would be in our way, and there's no way we could do it. Now that we have what I consider latent capacity in areas and footprints I do believe, one, it's a real good time for that aspect. So if on the core stuff, we can find it, and we identify it, on the mining side, it's definitely applicable, and we do need to have that ability to do it, and we can do it, and we got the facilities to make it happen as far as infrastructure. So.
Yeah, I agree with these guys. I mean, the biggest issue that we would see, I mean, talking with Aaron and Tyler, the areas they seem to be targeting is we have two seams separated by a 6-foot carbonaceous clay. Potential source for rare earths and critical minerals, unless you guys change your mind about that. But I mean, we already mine that as a separate bench anyway. Maybe, I don't know, 6 million tons a year. No, not that much. I think it's about 340,000 tons a year. We just throw it right in the backfill. I mean, we separate it out from the two coal seams. The other target source is our upper seam. The top 10 feet are not marketable. It's an interbedded coal and carbonaceous clay. The BTUs are there, but the ash is atrocious and the sulfur is ridiculous. And so it just gets taken out with our lowest overburden seam. And so the biggest challenge for us would be basically pushing back the 3 benches above it far enough ahead of mining so that we could keep, basically we'd have to start a 10-foot bench of that waste Anderson. And this will get into one of your other questions that you have on your list ahead of time. But one of the things that I think we would see as a challenge is, we to slow down so that we can parse out your rare earth target seams. And so we would need to strip that waste coal, that non-marketable coal, and stockpile it somewhere. And in Wyoming, you can't stockpile coal. There are kind of sort of ways, I'm not even going to go there. You're just not supposed to do it.
Carbon ore.
Carbon ore. Well, yeah. Well, we're going to have to get DEQ to recognize carbon ore as, if we could stockpile it, then we could set it aside, continue mining on our merry way, and then we're talking pilot scale testing. We're a small mine and we can generate, I don't know, 3 million yards of, we can generate 1 million yards of waste coal product a year easily without too much difficulty for us. Who's going to take it? That's a lot. It's a lot of material. And so you've got to get your testing and your pilot scales and everything up to snuff. But I mean, from a mining standpoint, I think we all agree it's doable. Jerry, you want to weigh in?
No, I can't agree on it. I mean, that's what we do. We move earth. I mean, that's the easy part. I think the complicated thing is just the extraction of minerals themselves. I mean, that's really got to be determined whether we figure out constraints, because we can mine it. We can find it. If it's there, we can make it happen.
Another opportunity that I see in the mines is there's incredible infrastructure in place. And can you just kind of comment on structure would be in place and what could be utilized to support a CORCM industry? I'm not sure everybody's been out to a mine to just kind of see all components that are there.
They're all different. I mean, I can't describe it going to be just like all these other mines. They're all different. They're unique. The majority of them are mass material movement. Ours is primarily done with we have 4 drag lines, 4 stripping. So the process is strip tops. All of our rock is drill blast, drag lines, uncover coal to the hopper. I mean, it seems simple, complicated, takes a lot of planning and execution, but to us, it seems pretty simple. To take another 6 inch in a truck and logistically, all the other questions that were answered before need to be answered. before we can do our part on it, but mines are unique. They're not all just cut and paste all the same. And up and down, all four of us would have different answers to that question. Our seam's unique. We mine a 25-foot seam. We use a road reclaimer, so actually just an asphalt grinder. So we slick ours down pretty good by the requirements of the power plant to meet their coal quality standard. That product is actually a waste coal product that ships to a power plant, Rosebud Power, north of town. If that doesn't meet their specs, then we waste it. So within that 25-foot seam too, there, if the parting layer, parties shale or clay or something in the middle of the seam, if that's greater than 6 inches, we do the same thing. We remove that. That has potential for these critical minerals too, but that's a waste product too. And on the bottom of the seam, that's where we get into our high sulfurs, which the power plant doesn't like. We just leave that on the bottom. So when we dig a hole, fill a hole, that's a waste product too. All of which could be thrown in trucks, stockpiled, processed. But like I said, we got to answer all these other questions first.
Just really quickly go back to the Cordero Rojo side. We had mentioned that we're doing about 40 million tons at one time. We actually have uniquely at that location, there might be a couple within the basin as well, where there's actually 2 loadout areas, locations. We're actually using one. The other one is just mothballed, idled. We do have some coal reserves right next to it, but it's all based on economics. So it has full rail access, it has full plant, has full silos, it has maintenance facilities, the whole works. And we've had a lot of interesting people come in and say, hey, we'd like to do coal to products. I don't know if they're snake oil salesmen or real, but we've had a lot of interest there. So the point there is, I do think there is, when I go back to the latent capacity in the basin, you can find it that there are these facilities that are very attractive, that have transport access, maintenance facilities, the whole things that are something we're trying to explore. I think there's an opportunity there.
Yeah, it'd be a shame to lose all that infrastructure to reclamation, in my opinion.
Yeah, repurposing.
So let me ask about supply chain. So we heard a lot about supply chain issues today. What current supply chain issues are you guys seeing in the mines?
Equipment parts. I mean, getting components for, we don't have drag lines or shovels. We're a loader truck operation. And some of you guys have been out, you've seen the size of loaders I'm talking about. It's not your little front end loader you see on a construction site on the side of the road. Our loaders can pick up 2 or 3 of those in the bucket. 45, 55 cubic yard buckets on these big Laterno loaders. Any kind of components for the loaders of the trucks. We bought a new truck. What year is it now? 2024. I think we bought the new truck in 22, early 22. It was a rebuild. We bought the frame, get the components and everything all together. It took 18 months. I mean, I think that's pretty standard across the industry, trying to find components for your stuff. Components in the plant, same thing. To crush and process the coal, you've got to have certain specialized equipment, and getting replacement parts that's what you're talking about for supply stream, right? Yeah. You guys, any different?
Even light vehicles, right after the COVID deal, it's just a simple thing of ordering a pickup or a fleet of pickups took over 1.5 years to get to where that could be. So it's getting better, but I think you're right, parts is definitely number one thing.
Yeah, so I asked that question because as we start to think about developing new industries, I think sometimes we kind of currently, right? So supply chain is going to continue to be an issue as we start working at rare earth elements and critical minerals. So what about, as miners, when you hear us say, okay, we're going to develop this brand new industry on critical minerals and rare earth elements, what is your first reaction to that? And what do you say, okay, you got to tell me X before we can move into this type of industry? What are the big hurdles you see for us for developing an industry like this?
My first response is the market. Obviously, you got to make money on it, right? And just like we've been talking about, is if you have an off-taker, an agreement, that stuff set up is the number one thing that would dictate it. As you guys mentioned, we can get the material, and mine it. We know that you guys, we are working on the technology, that'll come, but the market will dictate more than anything, in my view.
I was also going to say that, you know, we're in the business of mining coal and moving dirt, and like everybody said, we're really good at that. If we have to, you know, get these waste streams, you know, either above or below the coal seams, and we have to stockpile them if that's, you know, a value added type of thing. The other issue that's going to come into it is where are we going to put it? And I know you brought that up earlier, but we move dirt and we can't have stuff in our way. So, because you're on to the next cut. And so if you don't have a place to store it, we don't have time. It's on to the next cut and on to the next project type of thing. But also added to that is with the market being down, we do have time to kind of look at that now. You know, when we were 40 million tons or higher marketable on the coal side, there was no time for that. It was blow and go, man. You were just moving dirt and mining coal, and that's just what you did. But with the market the way it is now, we do have capabilities of, you know, looking into that kind of stuff and working with regulators and officials to see if we can, you know, update mine plans or get stockpiles or whatever we need to do there to, you know, further advance this core initiative.
I just wanted to kind of opine on, what is this pie in the sky?
Oh, yeah, okay, opine.
Are you considering?
So when we first started, and I get excited about every project like this that comes down the pike. I mean, new coal customers because they're going to do this with it, or they're going to do that with it, or they're going to make some kind of special alloy product, or they're going to do, it doesn't matter. Rare earth elements, I'm excited. Inject CO2 into the subsurface so we can maybe build more coal-fired power plants and keep the environmentalists happy. Yeah, I'm all for it. That said, I've been involved in the coal industry for 30 years. I've lived in Wyoming since 1978, however many years that is. I've seen a lot of ideas come and go. Who remembers the big coal slurry pipeline in the 80s? Boy, that was going to revolutionize the market, right? Yeah, what happened to that? And so I'm optimistic. I'm excited. I see the university and other entities really digging into this research, but I still in the back of my mind think, well, is it going to be in my lifetime? You know, is there even going to be a coal industry left? We all going to be shivering in the dark, hoping that wind and solar can handle base load? You know,
Hey, if we give you the mic, you can say whatever you want. Okay, so now I lost my train of thought. So actually, I just want to follow up on the market comment that you made, and we had that great comment on the last panel that it was the observation that the price of rare earth elements isn't controlled domestically. It's because it comes from one country. It's really the price is controlled at that point. And I think the observation was made was, well, how do you get over that? I don't have an answer to that, but I do know there's a few things that, you know, maybe should be explored. I think a guaranteed contract from Department of Defense for, you know, their rare earth element needs could be helpful. I think understanding what the environmental social justice scores of up my iPhone and see on the back that those rare earth elements were mined from a fair labor standards and environmental standards. I think those are little things that the market and consumers can start to ask for that will help to bring some of this industry back domestically. So that's just me opining. But you didn't come here to listen to me. So let's talk about regulatory challenges. So you mentioned one already, but what regulatory constraints are you currently facing that is also going to help not constrain, it will constrain a rare earth element and critical mineral industry? Here's your chance to beat up on DEQ. They're not even in the room. Friends of ours, friends of ours.
Should have done this first thing in the morning.
Which regulatory challenges you're facing?
No, I would like to talk about the marketing side again, if you don't mind. As far as Tech, what of our solution or thought process says, we know that we can't control the market. But just like a good investor, you should be looking at a diverse portfolio, right? So what we're trying to do is, obviously coal's our mainstay, right? Looking at other things like I mentioned, helium, and we're also looking at solar, wind, critical minerals, all the aspects of it. So the point there is if one does drop, you have the other ones to carry it and keep things moving forward as that develops. It's almost like the field of dreams. If you build it, they will come. Someone's gonna have to break ground. Someone's gonna have to develop it and start moving forward. The money being put into it is great. Identifying it, figuring out how to process it, figuring out who the off-takers are, that's the next steps. But once you start breaking ground, all those markets will start figuring that out, I do believe. But as if it does drop, then from our side of it, our company, we should will withstand that by having a diverse portfolio. That's the plan. So.
Okay, so from a regulatory standpoint, we have been approached, or it's been mentioned to us through different things with the university. Well, you know, if we do this rare earth thing, if we do this, and from private investors on different topics, would you be interested in putting a facility on your property? And I think the answer is sure, that would be a great idea, other than the fact that our air quality permits and our water permits and our just general permits do not allow for that. We're already under such tight constraints, and I mean, it's already difficult just to do the job. I mean, I'm attached to the environmental department in my current new understanding of everything that's involved from an environmental perspective. And people who aren't in coal mining, you know, even the people who work in the pit, they don't understand. We've got 3 different segments of the state environmental to deal with. We've got state engineers office for anything and everything to do with water and sometimes surface water, Army Corps of Engineers, EPA, RE, Office of Surface Mining, BLM. I mean, it's on and on. It's doable and we do it, but it would be difficult to be burdened, and I'm going off on a limb here, to be burdened with an on-site processing. A lot of places in Campbell County and Powder Basin in general, and probably you guys up here, there's opportunities to build processing facilities and collection, all those really cool, fascinating things that everyone talked about this morning that I barely understand, but the mines, but not on the mines property because of the regulations. I used to work for a guy who said government's purpose was to find a problem and exacerbate it. And that was over 20 years ago, and I've never forgotten that, because the older I get, that seems to be how things go. No offense, gentlemen. I know you're here trying to find solutions, but I don't think your cohorts in the East Coast necessarily are on the same page, but I'm going to go opine myself right off this.
I will say though that the support of the county, the city, and the state is critical to move that forward. That's the one thing we can't control.
Right.
Good example is the Campbell County and Gillette. They've actually, I think it was a Coal Creek, right? Yes, actually zoned that area as industrial use. That's a good step. Obviously, those things are need to be taken. Even go beyond coal. If we talk about the CK Gold project outside of Cheyenne, I don't know if anybody's aware of that. That is one permit that I've ever seen that actually had tailwinds instead of headwinds. It was supported by the University of Wyoming, the state, the governor, the whole works. the thing that why it went so well on that part of it was it didn't reside under the NEPA process because it was under state lands. But that point though is it takes those efforts from as long as you got the city, the county, the state on board with it, for us to say we're going to use something besides just mining coal at a mine is going to be required, and those steps are being taken. The NEPA stuff, we'll have to figure that out as it goes, but those are critical and needed to make that happen.
All right, we've got a few minutes left, but I want to talk about new advances in mining. What is the cool new tech that's hitting the mines, and where do you see this new technology going as we develop the mine of the future?
We don't have the latest and greatest, but some of the pretty neat things we're doing now is we've actually run drills remotely, like from our engineering office, approximately 6 miles away. Recently just went down to cat training grounds down there to investigate autonomous dozers. So I know they're doing it in Gillette, I believe at Black Butte, or not Black Butte, Black Thunder. One guy's essentially running 4 dozers at a time. So it's some of the things that we're looking at. GPS drones, I mean, stuff that's pretty commonplace to us, but them are 2 of the big ones that we're doing right now. Recently just bought an equipment simulator. So instead of training people and equipment themselves, where you're risking, damage, injury, breaking stuff, they just play on a computer, and it's literally just like running the truck. It rattles, it shakes, you throw snowstorms at them, slick roads, they get a test in not very nice conditions and not damaged stuff. So
anybody else want to comment on? Yeah, nice mic drop.
I mean, I know a lot of the new technology, I wouldn't say new, it's been out for a while, but it's more on the health and safety side of things. I know like if people go to MSHA training to get to be able to work at a mine, they'll put on VR glasses, so they can walk around a haul truck and do an inspection or go walk on a drag line. So it kind of just gives you a little more personal experience of what a mine's gonna be like, and before you actually even step foot on it. That's more on the safety side. I mean, I guess on our side, I mean, we've done a lot of drone work recently, that helps keep people out of harm's way. So you can send a drone up and scan walls or take pictures and that kind of thing that helps out either on the engineering side or even on the geology side sometimes, where you can actually get data points and not be in, at the face of the wall type of deal and have any safety concerns. So that's all I've got.
All right, we've got just 5 minutes. Let's open it up to the audience. I see Al, you've got a question.
Good question, thank you. Al Heron, Arcadia Critical Minerals. You talk about complexities of supply chains and so forth, but these guys are old guys. So what's been happening with the railroad? Your ability to move product. I'm not going to answer.
Yeah, that's an interesting thing. After the COVID thing, we talked supply chain. I think every single commodity had an issue in regards to getting their stuff to where it needs to come from. So everybody saw the issues with it. BN, they in essence had issues with their workforce. Things happen. I think the supply chains overall have gotten where they need to be right now. I think it's not too far off, Hal. I really don't think it's too far off, but yeah, so it was a daunting 2020 to 20 the railroad. They had issues with their staff for sure.
Were you speaking specifically in regards to the railroads about mines shipping out their? I don't think that's a railroad issue so much as it is other issues. I mean, we had groups from, I don't know about you guys up in Montana, but from Campbell County trying to get coal out the West Coast, up out of ports in Washington, and Washington absolutely refused to have anything to do with it. They were afraid of coal dust. They were afraid of spills. They were afraid of their own shadow, and it went nowhere. You know, I mean, we've got the coal. We could ship it anywhere that wanted to take it, but you got to get it there. And we have seen improvement in our train cycle times. I mean, they're 29, well, even before 2020, 2021, when our production was still up a bit, we were having hard times getting crews and getting the train. I heard you say you didn't want to go there. Dealing with the railroad has been, any railroad people in here? Dealing with the railroad has been the biggest headache I've had in my 18 years at the mine. And when I started, that's what I did, was coal quality and a whole bunch of other stuff. And so I dealt with the railroad on a daily basis. And I was really hoping Dry Fork Station would build another unit, because that would be 2 million tons a year that we wouldn't have to deal with the railroad. But the last 18 months, I mean, our trains are, it's Tuesday about 4 o'clock. So it's been good. But yeah, I know what you mean. I mean, we could ship coal all over the world if we could get it to the ports, and the ports would ship out. Adds a lot of money. I mean, tracks to mines in the basin, just 60 miles of shipping costs between the southern and northern part of the basin. So it's gotten pretty cutthroat in that regard.
All right, so we're at time. So I'm going to give you guys each 20 seconds to just wrap up, give a closing thought. I'm an eternal optimist. I would love to just hear like the go get 'em kind of thing at the end here, but I'll give you just a second to think about that. But I just want to comment on the supply chain. Think about how long the supply chains currently are for rare earth elements and critical minerals. If I'm a molecule of cobalt, I'm grabbed out of the dirt in the Republic of Congo. I jump on a boat. I have to take a boat all the way over to China, where I'm processed, manufactured. Then I get put into a battery, get on another boat, bring it all the way back over to the United States, where then I'm shipped out to the Walmarts or the Amazons around the US. So the supply chains for these rare earth elements currently are incredibly long. And so when we think about bringing that industry home, domestic industry, we are incredibly shortening, or have the potential to shorten a lot of those supply chains. Okay, so closing thoughts, Dave.
So despite my negativity with the coal slurry and everything else, you know, there's been a lot of flash in the pan ideas about what we can do with our energy, what we can do with coal. We've been working, how long has it been now, Aaron? 3 years? 3 years with Aaron, 5 years with Fred and the Carbon Safe Project. There seems to be some legs and staying power here with what's going on with the rare earth, the core CM, everything. And I find that I'm extremely optimistic about where this is headed. I just hope we can get it done and accomplished in a timely fashion. Who was it? Was it you, Ken, that said something about before China shuts us off? You know, I mean, we're kind of up against, we should have been doing this 20 years ago, but we didn't see it coming, or we chose not to look. So anyway.
Ditto. No, you know, on our side, at least for EdTech, I think, you know, I think it's definitely a good thing. And part of me thinks that, you know, we're coal miners, right? And we've always been coal miners, and coal miners really don't like change. But I mean, something's got to change sooner or later. Coal's not going to be around forever, or, you know, power plants or regulatory or however it's going to be. So, you know, I think it's better to be on the leading edge of it than being on the tail end trying to, you know, catch the train type of deal. So I really think it's a good thing. I mean, with Aaron and Tyler, it's been great working with them, and I look forward to continue working with you guys.
And as far as the federal government, the only thing that will actually ever move that group is what I call a burning platform. Burning platform means the 2035 sounds like is what I heard today is we need to do something in regards to supply chain, creating critical minerals, rare earth minerals, and then providing funding for it, right? That's the deal. So I believe, I'm a firm believer in action. The next step is, what I heard is, right? So this is a regional issue. It's not a mine-specific issue. It's not a city-specific issue. It's not a state-specific issue. It's a regional issue. So what I would ask or look for is this group here, move forward as a group, requesting funding to move this forward so that we can figure out how to process it and how to create off takers and all those stuff to move that forward. We need to break ground. After we find this stuff, we'll figure it out, but that's what we need to do. It's a regional deal, and that includes Montana, Wyoming, all the mines that we're talking up here. So, wow, that's my soapbox. There you go.
I don't have a whole lot to add to that, but prior to my stint in coal mining, they mine precious metals. And this kind of seems similar to that. So Pegasus Gold, we had properties all over Montana, Idaho, not properties, potential mines all over Montana, Idaho, Wyoming. Lots and lots of exploration. I think we developed 4 mines. So I think that's the kind of state. So that's kind of rough. I don't know if I'm that's practical, just use them. Correlate back to the expiration days. And I think that's right. It's there somewhere. We just got to find it, learn how to extract it, learn how to process it. I mean, if you do that, it's economic.
All right, let's thank our panel.
All right, thank you. We will now move on to our last panel of the day. And this panel will be moderated by Selena Gerace from the School of Energy Resources. Selena works on our community engagement and social science pieces. Our panelists are Jim Atchison, Executive Director. We have CJ Stewart, who is the Crow Nation Energy Director. We have Jim Ford, who is the founder of Waypoints Wyoming in Gillette, Wyoming. And we have Marty Brown, who is the Director of Workforce and Community Development at Gillette College. And this panel is on coal communities, workforce development, and the path forward.
Oh, yeah.
Now, can you hear me? Okay, great. So I just saw CJ. I think he just stepped out of the room, so he should be back in just a moment, but we'll go ahead and get started now because I know that we're headed towards so thank you, Aaron, and thank you to all of our panelists for joining me today. I think this is a really important all of the work that we do. So I think it's a good conversation for us to finish up. Hi, CJ. Thanks for joining us. All right. So all of our panelists, Jim, get started.
Certainly. Thank you. Officially, I'm Jim Atchison, Executive Director of Development in Colstrip. We are a regional nonprofit economic development group that does whatever we can. Economic activity, community activity, Wester, Rosebud, Powder River, and Treasure. So that's basically Miles, Colstrip, Hysham, Forsyth, etc. Our organization has been around since '97. I've been there since 2001, and I have a lot of passion for what we're doing because we get to help people economically, specifically economically for people. We work with businesses on a day-to-day basis. We work with to do whatever we can to bring information and funding back to my 4 counties.
And we've been very successful at that. And of course, being experienced in the energy industry, of course, with the coal strip power plants and the mines and all of that right there. So we have a staff of 4 people. 2 of them are remote. And we hired those 2 before remote was even a word. You know, we just knew we had good people and we hired them and we made it work. We get up every morning and go to work and help businesses succeed. We build the economy up, or attempt to build the economy up, versus what some NGOs are doing, kind of just the opposite, you know, and you all know what I'm talking about there. So we've had a good track record there, and we have probably 4 tools in the toolbox that we do things. One of them is planning, besides business services, business financing, and other advocacy services. But under planning, we ran into this back in 2015, 7 years, 8 years ago. And that was the Clean Power Plan. Together and fought that as much as we could back in that era. But the coal strip people kind of came to Jim, we're kind of nervous here. We need to diversify our economy. And we know you do that on a day-to-day basis, but nothing more urgent and focused, create some sort of urgency and diversify the economy of a community. Well, it all sounds pretty darn easy, right? And so we started down that road. We came out with our coal strip economic diversification strategy in 17, 6 years ago. And we use this ever since. 6 goals, 17 strategies. About half of them were energy related. Number one issue, broadband, additional broadband capacity in coal strip. This summer, 6 years later, we are adding finally an $8 million into Forsyth. Just a great plus for us, and that's one of our diversification projects. Another one was a basic of a regional marketing and that the energy industry provides for our community. And I would be in Montana, what we have in coal strip, a little town of 2,000, and so we also have Business Innovation Center. We need to talk more about that. We came up with the plan to create a one-stop shop location for entrepreneurship training and conferences. This would be perfect, but we haven't found a way to kind of get that built yet. The bids came in and they were a little high, a little inflation, and so we're back to the drawing board there. Hope we're going out for bid for about a 6,800 square foot building. Looks like you have one in Gillette, so I'm going to go down there and check it out with those folks here and see how they did that, how they funded it, how they got around all the things there. So we've been doing diversification in coal strip for quite a few years, and every year it's a little different, a little more elaborate. And during this process, and we thought it was our idea, but obviously I'm speaking to the choir here a little bit, but value added ag is huge in both states. So we thought, well, God, there's a lot of value added energy commercialization opportunities in coal strip. Didn't really realize that you folks were doing a lot of that too, and that's great. We need to keep that collaboration going. So we're looking at obviously rare earth elements as well. We funded or commissioned 4 studies. One of them was rare earth elements. All of these were completed back last year. We funded graphene research. Joe Clench is here with that organization. We funded some flue gas capture and carbon capture commercialization opportunities. And hydrogen was the other one, gasification of hydrogen using coal, not natural gas, but using coal as a feedstock. I think we were one of the few that were still looking at coal to trying to diversify that. So we've been very busy. We're very excited about the future. And quite frankly, after 22 years of being an never been more excited about the future of our corner of the state and that community than I am right now because of what could be coming and what most likely will be coming for our end of the state. So thank you.
Hi, good afternoon. I'm going to continue on a theme here, I guess. My name is also Jim. I'm Jim Ford from Gillette, Wyoming, and also have some experience in economic development with a number of years on the Energy Capital Economic Development Board of Commissioners. I stepped away from that role just recently because I made a mistake and put my name on a ballot. and I got elected to the county commission there in Campbell County, Wyoming. So just into my second year on the county commission. There are hard lessons, but lessons nonetheless. I also am here today as a small but growing owner founder, looking for opportunities in industry for value-added processes for coal and decarbonization. In that sense, I have the privilege of getting to work for the, I'm going to have 6 or 7 bosses in the room today because one of our jobs is to manage the facilities operations at the Wyoming Integrated Test Center. That's the large-scale CO2 capture, conversion, and sequestration facility we have north of Gillette at Dry Fork Station, adjacent to Dry Fork Mine. Also, more recently, we've taken on a contract with Energy Capital Economic Development to manage a sister to the Integrated Test Center. It's the Wyoming is a I hesitate to say incubator, proving grounds for technologies to scale speed to coal to products technologies or non-fuel uses for coal. We also have the University of Wyoming as our first project developer and tenant on site there now with that pyrolysis space project that Trina showed us some pictures of this morning. And then lastly, we tried, this is from the local government perspective and also kind of the industrial entrepreneur perspective about how to get out in front of some of these trends. The economic development perspective, the academic and science and research perspective that's so well demonstrated in this room, or represented in this room, also tends to move a little slow sometimes for other folks that need to engage with you to make your efforts, I'd say, worth something in the financial sense, where finance is concerned, where industrial partners are concerned, there are oftentimes different drivers than what we have in the academic sphere. And so I try, without upsetting any of the folks, to provide a little healthy tension from this industrial sense and pulling or pushing on the science and academic perspective. And we've done a couple things there in Campbell County that I think are going to be proven to be very unique and very valuable in just a few years, where I think about, core CM, carbon ore, and where CO2 capture is concerned, how do we close the carbon loop, so to speak? We have large scale mining that is still valid in coal. We have newer, 10 years, 15 years old or less power generation. These are coal plants that you can justifiably support additional investment beside them for CO2 capture. Some old coal plants can't. With the research in capture, sequestration, and coal to products, we've really got a unique scenario happening, and we've been selfish in a certain regard, paying attention to what happens at home. But I really do like the perspective of the last panel saying that regionally in Wyoming and Montana, in states where we can make up our own minds about things sometime from a political sense, as long as we, still provide something to our customers who are typically outside of our space in areas we can't control decision-making. All of these efforts will help us to continue to market our basic energy mineral resources to customers in a way that's sensitive to the realities of today. So.
You can take either of them. I was just going to say, I know you have some slides, and do we have a pointer?
There's just 2 slides. The
Oh,
first
okay,
one
it's
here is
right
just
there.
kind of an intro thing there. Boy, do I feel out of place. I'm used to talking to a whole bunch of coal miners that don't want to be here. They're just waiting, looking at the clock and want to hurry up and talk there, to a group that is really excited to be here and about new and innovative things there. But another thing there, thanks Aaron for letting me hang out here. And I want to let you guys know I'm part of the Boulder and Dirt Club. The problem is where did we put it so these guys don't have to work so hard at finding this stuff there. So put a little value behind that. I've got 38 years in the coal mining, and 25 of those years twisting wrenches, and then the rest of that time was in technical training. And now that's led me to, after that, I ended up at the Gillette College, and I started there in the MSHA department. Now the MSHA, their little history there, right after that, where MSHA become an authoritative factor throughout there. So before a flight goes done, yeah, you got to go through underground. There's like 40 hours of it. There's surf. You got to go through 24 hours. And Aaron got to do it there. Tyler, and those are 3 of the days that you'll remember forever, won't ya? And here's a little tip. Don't ever lose one of them 5,000-23s, because if you can prove you as a coal miner, you never have to go through that again there. But the exciting thing of it about there, and I don't know where Kyle ran off to there, but the VR side, you guys mentioned a little bit about the VR side there. We got the blind spot program going on. We got a mine tour program. We've got some more innovative, some more exciting things coming on there. Middle of next month there's going to be a big VR thing that we're going to go to down in Laramie there and bring more of that together. So all the harm or all the hazards without any harm there. And we can, a lot of times we'll talk about equipment. People have no idea what they're talking about. They're just back there doing the bobblehead bit there. And we can put you in this piece of equipment. We can show you how hard it is to see around you, and why it's so important to get out and do walkarounds there. So now I'm into workforce here. Started that in August, so it's not that far along that I've been into this here. Oh, okay, it went on to the next one there. And like I said, the Gillette College there, I'm on the career and technical ed side there. So we've got the maintenance, diesel, electric, welding. One cool thing in welding that we're just coming on to. Have you guys ever seen the place Rosette? There's a little white Quonset hut right alongside the interstate. They build boats there. They build boats there. I mean, in the middle of Wyoming. Well, that's kind of crazy there. Well, come visit me here. So not only do you got the burn and rod and stuff like that, we can teach you that. I can also drone pilot there. We do a little LiDAR scanning if you want to get into that, and get you involved in there. And then we get out into the back to the tech side there. It's a 2-year program. First year is for certificate, that on. And Gillette has got such a thirst for skilled people that we've got people knocking on our doors or wanting to see what our kids are like right there. So we have that strong thirst. And then the other battle cry I hear all the times there is skilled workforce outside the schools there for our non-traditional students there. So that's where I can come in out there. I can offer some that. Or doing a cool thing about it is I can come to you once stuff. And then there'll come back. So that program with the whip there, we're just finishing up. We're getting ready to go into phase 3. Phase 3, it's got to be due by May 7th. There, we're looking at equipment to move forward there. So what's next in this workforce advancement? So right along there, I heard chemistry there. Well, I'm not too much on the, but we need to talk. That because there is gaps. There's definitely some gaps out there, and then fighting ahead of them beforehand there. I can do 12, 24 volt DC, 6 mobile air conditioning. I'm also a proctor, so I can do test preps for the EPA tests there, fill them out, send them off, come back. We're working on some 6 understanding the only 608 look close is right here in Billings there. So don't mean to steal any business from you guys, but I'm thinking about doing some testing. So going there. Lift safety, boom truck, hydraulic crane, you can do all that as well there. And then another cool thing, take a schematic from a piece of equipment you guys got, come out and take a bunch of there, and then I can put it on a part there, bring that schematic, click on a component, here it is there, and tell you how it works. And if that still ain't enough for you, come see me. I got Z space and throw a 3D model up in front of you. Stuff you guys are listening to and talking about. Roadblocks I see is the NIMBY crowd, not in my backyard, those folks. And then here a while back, we were on a, and I don't remember who said it there, but we need to make things, I think I wrote it down here. Was sexy and there. Need to bring this to people there. Well, I can handle the sexy part there, but I need a little help on this holistic stuff there. And then one of the things there when I was coal mining there, ash. Man, ash, everybody always got excited about ash. There's too much ash, too much ash. Then I come here, everybody's excited about ash. Boy, we want to play with your ash, you know, stuff like loopy here, there. But one last thought. That line that you guys are talking about, dinosaurs, we got bears. So watch out for the bears there. But last thing on the list there is with this work grant program there, the WIP program, we're standing up a CDL program in Gillette. We've got our simulator in place. We've got our director in place there. We're launching, looking at June 3rd for our launch date. But after today, I see I have to put on there, don't slam your fingers in the door. So hats off. Thank you guys there. And I'm going to turn it over to CJ before I get in trouble.
I just wanted to thank everybody. It's good to be here and you know, be around friends. You know, it's kind of rare nowadays, right? You know, I was, you know, for those of you that don't know who I am, I'm CJ Stewart, Conrad J. Stewart. You know, I worked with you know, heavy equipment for a number of years, you know, went to U of M, graduated over there, you know, worked for the BIA road department, you know, ran equipment. They kept trying to recruit me out to Westmoreland but you know, we were on a 1040 job, what they call job attach. And so it's kind of iffy back then, you know, you jump on with Westmoreland and work 3 to 4 months real hard, make good money, and then get let go and then quit the job that you just now went for and then don't get no unemployment or, you know, I couldn't do that. And, you know, so I said, I can't go. So next year come along, you know, they recruited me out to Westmoreland and we, you know, started coal mining. They wanted me out there as a dozer hand and whatnot. Led to lead loader hand and worked at the drag line, ground cat, you know, and just getting familiar with you know, I mean, it's a coal mine. It's the coal mine that the Crow tribe has, and you know, being there, you know, and working and it means a little more, you know, and you know, actually you're putting food on the table for your families, and a lot of the folks that work out there are all the firstborn sons or firstborn daughters, the families, you know, and so it's a privileged position, you know, on a reservation. You know, you got the Yakimas, and then their privileged jobs up there are irrigation, you know, because they got a lot of water. And over here, it's our privileged position is coal mining. If you wanna go that route, you know, and there's nothing wrong with eating out of a box, you know, middle of the night or middle of the day, you know, and there's honor in it. And you know, aside from all of that, I got elected, and, ran for office, ran for the legislature. I sat on the council for 2 terms, and both terms served at 4 years apiece. And right away, they elected me as the vice chairman of the Natural Resources Committee. I served on that for two years, the first 2 years, and then the remainder of the 6, I served as Natural Resource Chairman. So basically, you know, just like Congress, you know, everything goes to the committee first before it goes to the floor for a markup, you know, for a markup vote, you know, to get marked up to the floor. And so with that being the case, you know, I was infrastructure chairman for those 8 years, natural resources chairman for 6, vice chairman. I was in leadership. So basically 2/3 of the tribe's, you know, issues were at my doorstep, you know, at all times. It was very, daunting. You know, I didn't have to work it as a full-time job. So I was working out at the coal mine too. So for about, you know, good, maybe 5 or 6 years out of the 8, right? I think it was about 6 years. Shoot, I'd be working graveyard shift all night, go home, sometime, you know, jump in the shower real quick, have some coffee, go back to the office, sit in on a meeting in the morning, go back the afternoon, go home in the afternoon, take a nap, and go to work. And I did that for 6 years, you know, and it's not hard when you mentally have a picture of your kid's face, you know. And there's times like that. You're out there all alone, running dozer, loader, whatever. You're out there in the pit, out there in you know, spoil piles or whatever you're doing. A lot of times, you know, coal mining is lonely. You're out there by yourself, you know. And what you do, you know, the cause and effect of that, you know, you definitely can change the world, just the machine. So, you know, with all that being said, I was, you know, I got to serve on the coal board. I was appointed on a coal board, got to serve with some people, you know, John was there, kind of mentored me along with the coal board, you know. And amongst my peers, I was able to be voted in as the vice chairman of the coal board. It was the first time a Native American ever sat on the coal board, let alone, you know, just a Crow, you know. And then, you know, later on, I got called in. Secretary Zinke called me in. Well, when he was on in Congress, 114th Congress, he asked me to serve on his natural resource advisory committee. And so, again, that was a great honor. You know, being the only guy in the room, you know, Native American, and then, you know, I'm sitting there amongst a bunch of CEOs and presidents of companies, you know, and they were all going to vote on who's going to be the vice chairman, because, you know, when they appoint the chairman, and they appoint everybody else, and the members appoint the vice chairman. Well, they voted me in as the vice chairman, but, you know, it was kind of really humbling, you know, because I knew who I was sitting there with. You know, I was sitting there with some honorable men trying to make some money for their families as well. And they probably had some money in their bank accounts. You know, I'm sitting there with $10 in my pocket, knowing full well I can put $10 in, because that was back when we had the gas wasn't as much, right? So I was able to put in 10 gallons, and that'd be about $10 worth, you know, about 3 gallons, maybe a little more. I knew I was going to be able to get home, you know, and so that's all I was thinking of, you know. So, I mean, it comes from humble beginnings, you know, and, you know, we don't come into this piece knowing everything, you know, and that's what this is important, what the importance of this meeting for, you know, and that's what I see. So, you know, I served in that capacity. Of course, you know, Secretary Zinke moved on to being the Secretary of you know, of Interior, and he was overseeing 12 time zones, and, you know, all the large land-based tribes, and, you know, and in that, I'll tell you a little quick story. You know, I'm not going to be as long as some of these guys here, you know. Shoot, these guys, they got a lot to talk about. Boy, they're important men, you know. They got good stuff. And, you know, when he was still a congressman, he asked, and we know he got appointed. You know, I was working out at DC, you know, I was helping out Ryan, and, you know, at the time I was working out as a consultant. So, I mean, I didn't have to worry about, you know, the CYA policy of BIA or the VOI. And, you know, I was able to work the Hill and do that kind of stuff without any interruptions. So I was kind of valuable at that, you know. And so Ryan asked me, he says, well, Secretary Zinke asked me, he says, I want you to be the Assistant Secretary of Interior for Indian Affairs. He asked me to be the Asia. And I thought that was a great honor, you know. I thought that was really a great honor. And I told him, I said, yeah. I said, yes. And I was even at his hearing, you know, and all that. And he's the only one there, and only Native American in the room. Just plumb packed, you know, a bunch of naysayers, you know, and walked in there. It was good to see you on the delegation. You know, I know, you know, Senator Daines and Fester and all the folks, you know. you know, and, you know, coming from a small community, you know, we joke, you know, it's PC kind of a joke, you know. So, I mean, it was like that. And I don't know if you guys understand, but at the time, Senator Murkowski at the time, at the beginning of the Trump administration, you know, Ryan and Senator Murkowski bumped heads. And we sat down, he said, you know, as men, you know, me and Secretary Zinke sat down at a place called Hawk and Dove, and we were having some wings. And I told him, I said, as a man, I was always taught we have some coffee and reason, you know, sit down and have a discussion. You know, this woman's on your same level, you know, talk to her as a equal, you know, there's some coffee with her, see what happens, we'll see where it goes, you know. Later on, and at Fox News or wherever it was, they drank a beer together, you know, and buried the hatchet. And I told him before that, I said, she's going to ask you in private, probably ask you some, because I kept my ear to the ground. I was pretty good about doing that. So I knew that she was going to have somebody that she wanted from Alaska overseeing that area. And that was Tara Sweeney. And I knew she was going to ask for her because they worked closely together. So I told Ryan, I said, no love lost. If she asks, give it to her. I said, if it's going to secure our position with the committee, I said, let's do it. And he said, well, they're going to complain about the lower 48 because she's going to handle all the 223 Alaskan tribes. And I mean, I ain't going to deal with that. Who's going to catch that heat? I said, I'll catch it. I said, put it on me. And so he appointed me as a senior advisor between him and Tara Sweeney. But, you know, I mean, at that time, you know, there was a lot of discussion, even in the Trump administration, about, you know, making policy against coal and whatnot. And so, you know, we had a lot of, I call them Obama nights, you know, once they established the SES process under Obama administration, you know, Obama was able to install all his career staff. I don't know if you guys knew that, but that's what's going on up there. And so, you know, I came back during COVID. You know, we set up a CCUS roadshow. First one was in the Ronald Reagan Trade Center in DC, right on Pennsylvania there. And it was packed out. We had to turn people away. I mean, it got too packed. I mean, everybody's interested. And the next one was supposed to be Houston, New Orleans, and like going around 6 cities. But COVID hit, you know, we got grounded. And then after COVID, you know, we were experiencing an election as well at home. The chairman asked me 5 times. He says, I want you to come on as an energy director. I agreed finally. And, you know, the way I was taught, you know, you don't change, you know, horses midstream, you know, go all the way, you know. So that's what we've been doing. And the chairman has established an all-above approach to energy. We're not canceling out coal. In fact, you know, we're going to be probably making some announcements here in the next couple of weeks here, just to, you know, settle some nerves here. I know you guys are talking. And so I just, you know, there's some good things coming along the horizon, you know, and we understand that the Crow tribe has a responsibility in this piece because we're the largest private coal owner in the nation, 10% of the world. And we have a big responsibility, and then we can't walk away from this. And so we got to continue moving forward. And I appreciate the gathering here today, the strategy. We have to have more of this. We get in these meetings where you got some folks in the back and want to be hecklers or, you know, things like that. But, you know, the folks here, you know, we care. You know, we care about what's going on. We care about the workforce development. You know, we care. I mean, that means a lot to us. You know, they're trying to tell us that, say, hey, you know, take your workers and go and get trained up to do solar. What's that? Sun gazing? You know? They told us to go and train our workers to do hydro. And, you know, we have an exclusivity agreement, and I'm working on a hydro power plant right there at the bottom of Appleby, and we're getting it moved. It's going. It's actually going. But, you know, that's the thing. They tell you that they want to transfer you here and there to these, and your workers and whatnot, but, you know, I had to say it to the gentleman when they were talking to me from the IWG, you know, the Intergovernmental Working Group. for coal communities and power plants, whatever. I said, have you ever been to a parking lot of a wind farm? He said, no. I said, have you ever been to the parking lot of a solar farm? He said, no. I said, you been to a parking lot at the refinery? No. Have you seen one? He said, yeah, I seen them. A lot of cars there. Yeah. Have you ever seen one at the coal mine? Yeah. Cars there all night, every night, all 24/7. Yeah. Then why are you trying to have me go and do something else when nobody wants to be at what you're trying to do? You know, there's no parking lots there. And then I got to look at the votes, you know, and jobs are votes. And we satisfy these jobs, give them good work ethic, and then work towards doing something great, you know, with our resources, can create all kinds of opportunity for the region. In fact, the Crow tribe, we did a Harvard study in this region concerning our coal, and we were at in the billions, hundreds of billions in the fifth degree of the ripple effect of everyone it touched. It's just our small mine. And so imagine if we had more to work with. But I just wanted to keep it at that. I know we have some time here. I don't want to take up too much of your time, but I just appreciate today. Thank you.
Thank you to all of our panelists. Aaron, I know we're about at time. Can we do a couple of questions? Okay, wonderful. So I'd love to hear from our panelists. You've all talked a bit about the efforts that our communities are making in diversification. And you all are in these communities and seeing how those efforts are going. Can you talk to us about how communities are faring with diversification? And what are some of those benefits to it? And what are also some of the challenges that you see in diversification?
I'll start that one. I'm going to jump on the mic first.
Okay.
You know, I heard someone talking about rare earth elements. You know, I think a gentleman was over here like, what's going to happen? What are we going to do? You know, kind of a thing. You got to take advantage of, you know, the tribal community sovereignty. That's what I'm going to tell you right now. These guys are using our sovereignty against us as U.S. citizens by going with someone else that's not a U.S. citizen. That's treason. When we have the resources and we have the citizenship that are producing these resources or have the ability to, first and foremost, ask yourself, who owns it? China don't own it. So hell with them. Who owns the rare earth elements? Does anybody know? Who owns the critical minerals? Does anybody know? 90% of rare earth elements are in and on Indian country. That's your answer. I think the gentleman over there is asking a question. I think we can utilize the sovereignty. Government is trying to go that way because they're trying to BS us. They put together last year or a couple of years back, we had an energy meeting back in Vegas. When I got back, I had an email from Grant asking me to sign on to an MOU with both Navajo and Hopi, agreeing to transition away from coal. In that, they cited two acts. And that was even before I did the metadata on it. You know, there was a legal document altogether. But the metadata on that, or not metadata, but the two acts that they cited were dealing with and critical minerals. So they were trying to shut us down, and then they're trying to use their paternalism to take over on the and critical minerals piece. That's what they were doing. And we didn't say yes. So kind of the hell part was kind of quiet, but we said no, you know. And the reason why we said no is because if you look at the Constitution under the Fifth Amendment, if they, you know, eliminate your ability to your resource or develop your resource, we wouldn't have a claim to put in for a federal takings clause. We wouldn't be able to put in a claim for just compensation. If they come after us like now, that'd be a stink on them they can't wash off. But if they put us under their wing, we're dead. And we could never go after our resource. And so we said no. and they came after us. But we rose above it. They hit us with audits all the way back to 2012, put us under critical high risk, put us under a sanction no pay on the list. But thank God our chairman, all the way down 2012, he submitted and corrected all the audits and submitted them into the clearinghouse. And now we're out of the critical high risk. We're out of the no pay list. So that's a big achievement that the Crow Tribe has done, that we really never had to go there. We were already working on it, but federal government put that on us, and it hurt us for a little while. But now we're moving towards, achieving what we were trying to get done with our resources.
So just a couple thoughts on the diversification. There are communities in coal country that it's a much more pressing issue to find a way to diversify away from coal, whether they have one mine or one power plant or one of each, and the first one that falls takes the other one with it. Colstrip is like that to a degree. I think of Hayden or Craig, Colorado, some others. In the Powder River Basin, I think we're lucky in a respect that the exporting mines, serve, I think, still 85 or 90 different power plants across the country. And so every time one of those power plants gets shut down, we do see a step rate change in our production, but it's not the only job in town. And so it's different in different places. And I think that we've got an advantage here in the Powder River Basin, particularly Wyoming and Montana in general. But as far as diversification goes, I'm not particularly interested in diversifying away from coal. The options, if you don't have a river, or as CJ said, there's no workers in the parking lot at the steal that story, by the way. So I don't have that much interest in diversifying. Nothing pays like minerals extraction. The best thing to do with coal is to burn it for our nation. To do it the right way, in an environmentally sensitive way. And the coal industry has continued to answer all the environmental pressures, over 60 years of SOx, NOx, mercury, particular problems. And so is CO2. It's just an engineering problem. The thing I think that we have in our advantage is that we should look for ways to multiply or amplify the uses and value of coal, not diversify away from it.
Yeah, thanks, Jim. And I would echo some of that too. In Colstrip, we don't like the word transition. It's fighting words, and I'm glad to hear you say that, because we use the word supplement, and of course that goes down the road to diversification. Of course, we think we have 15, maybe 20 years of coal and left according to the current situation. But as far as diversification goes, obviously, new jobs, new tax base, of course, or you're saving the current jobs or retaining the jobs or the tax base. But it's really tough in these rural areas around the country. I hear all sorts of horror stories. There's no capacity, nobody helping them. One state I was talking to, a group like mine, and they had no state help at all. And I have to admit, we have pretty good state help in Montana, in my opinion. And whether it's the coal board or other Department of Commerce people like Cannon Lurkins, who is here, and the new Director of Commerce, Paul Green, fantastic help for what we're trying to do. Also, we've had some pretty good help from the federal EDA on some different grants, the Assisting Coal Communities funds that we've used in Colstrip. But Colstrip is changing. We're not closing.
I guess I'll finish up with Gillette. So if there's a dip in coal, you'll see people swing over to the oil side and vice versa. Go on there. I don't know how many people in here know of LNH welding, LNH industrial. They're trucking along. It's kind of like, hey, that's an LNH truck. Hey, I know that guy. They're putting mega doors in at the Smithsonian there. So that's how diversified that company can be. So we can look at them and examples there, and just because with a little bit of technology, a little bit of changing and stuff going on there. So again, that's kind of my role, to see what's going out, see where I can help and help people make a change in their lives.
Thank you all. Reach out to me or any of our panelists to ask some follow-up questions. I'm sure that you would be more than welcome to do so. And thank you so much to all of our panelists.
Okay, well, this brings us to the end of the day. I would just like to say thank you once again to the whole Corsium team and the broader SER team. Thank you to all of our panelists. I really learned a lot this afternoon, so much appreciated. Thank you to Representative Perry, Senator Ankney, and Mayor Williams. Really appreciate your perspective on the energy and mining landscape in Montana. So I'm going to close the day today by just saying I think there's a lot of opportunities out there. And I was optimistic about the critical mineral and carbon ore path forward in the Powder River Basin before I came here today. And I am even more optimistic leaving here today. So thank you for your participation and safe travels.